Okay, good morning, everyone. So, shall we start? Uh, Good morning again, and this is Tilina Patrana from LKNOG committee. So, Lanka Network Operators Group, or the LKNOG, we welcome you all to this webinar, which marks the fourth appearance of LKNOG conferences. Um, LKNOG is kind of a non-profit community-based initiative, which we target the knowledge sharing and the collaborative aspects among the network operators in Sri Lanka. So the objective of our forum is to provide a local and regional platform to discuss the operational issues and the technologies that interest network operators in Sri Lanka and even in the South Asian region. So this initiative also, we aim to unearth local talent and the resource personnel from Sri Lanka. So most of our resource person or resource people will be from Sri Lanka. So they are very keen in contributing towards capacity building and knowledge sharing activities at large. So the last 3 years, we had multiple multi-day conferences, which included long tutorials, workshop sessions, conference sessions, and then we tried to help the community in many ways. So doing the same thing this year, we had a lot of big plans, especially for 2020. But unfortunately, due to the COVID-19, we couldn't done any of those within the year. But finally, what we thought of doing is like trying to get all the operators into the online platform and then do a single day conference and share what we did within the year, or maybe the new things that we came up within the past few months. So we can start now without making you lazy with my this boring talk. I would like to introduce our first session done by Tashi Finsu from Epinic, tutorial session, and with Epinic trainers. So if I talk about Tashi, Tashi is the training delivery manager for Epinic, and he's there for some time in Epinic, and he's a person who had, so according to Tashi, he's a person who had a lot of hands-on in telco area, and now he's trying to teach us how to do things. So Tashi and Dave, the stage is yours. We can start.
Right. Thanks, Telina, for that. What Telina was too polite. I think I requested Telina to let the crowd know that I used to run a network. I no more do that. Anyways, without further ado, let me jump to our slides. I was trying to do a mix and match of slides. All right, let me do that. So, Telina, just to confirm, what's the timing that I have? 60 minutes, 90 minutes?
Actually, you can go for 90.
90 minutes. Then I might use the longer slides. If it's shorter, I might use a shorter slide. So I'll go with the longer slide. But I would like to apologize to everyone. I may not go through the slides in detail. I'll just try to do whiteboarding wherever possible. But can everyone see the slides that I've shared?
Yeah.
Okay, thank you. And before I share that, on the wiki page, can you, let me share the wiki link. For those of you who are interested in getting hold of the slides and also the lab guides, I'll be doing a few demo today. Maybe I can share this in the chat. Where is the chat? Oh, I have no chat.
Tashi, that link is on the LKNOG website.
Okay.
It's shared.
So I would assume that can I assume that everybody has access to this wiki page that I'm talking about here? So the slides are here, how to install validator lab guides are here, how to do it on a router, everything is given here. Can I request everyone to make sure you're on this page? Because if you have any questions, I would like you to please type those questions in this document. We have given lots of references here. And as you can see, those of you who are shy, South Asia, generally we have shy people. So I'll request you to type in your questions here if you're too shy to ask using the audio. So I hope that one is clear for everyone. And we won't be doing any labs, but this is just for you. But I'll do a quick demo at each and every step, how to create ROAs, how to install validators, and how to consume that from a router's point of view. All right. So with that, I'm moving to the slides. All right. Can everyone see the full screen mode now?
Yeah, Tashi.
Okay, thank you. I'll be moving around, so I may not be on the camera. I might be whiteboarding. So please don't mind me if you don't see me on the camera. I might as well turn the camera off. So let's have a look at what it takes to secure the internet routing with the RPKI framework. So before that, we will look at current tools and techniques on how we currently do things pre-RPKI framework. With the RPKI framework, what are we able to do? And what's still missing? What's still missing in the whole RPKI framework, right? It's not a bulletproof solution. It still needs a bit of work, but we'll discuss those things. Okay. Just a quick acknowledgement. I've stolen ideas, especially from both Jeff Houston and Randy Bush, the godfathers of RPKI. Before we jump into RPKI, just a quick look at few recent incidents. I won't go through every incident. I'll just select 2 or 3 incidents, although there are lots in the slides. Um, late this year, September, Telstra was involved in leaking out close to 600 prefixes onto BGP into the global routing table. Right? So what was weird about this one was Telstra was taking aggregates from the peers that they have, but somehow they were breaking it into more specifics and they were leaking out those more specifics. They were leaking out those more specifics to their neighbors, right? But what's weird for me is if you look at the BGP stream or BGP replay, you see this is Telstra. AS1221 is Telstra Domestic Australia. AS4637 is Telstra Global. 6461 is one of the largest networks in the world, Zayo, or I think it's AboveNet 6461, one of the biggest tier ones out there, right? So surprisingly, before this, what happened was Telstra AS1221, they claimed that they have started doing route origin validation, right? So it was quite ironic that they did inbound filtering based on RPKI, but they were the ones who were leaking out routes to the internet. They take someone's aggregates, break it into more specifics, and leak those more specifics out to the internet, right? So what was happening here? Later, of course, they came out, they wrote a blog post about what actually happened during this incident, because ideally, anything you locally originate in the RPKI framework, any router, you will see that as valid because you are locally originating that route because you have that subnet connected to your router. So it's seen as a locally originating route. And that's why it's always seen as valid. So later in their blog post, it kind of confirmed our analysis where they said that it was error in one of their automation tools, which actually not only leaked those more specifics out to the internet, but they also originated those more specifics. Leaking, I think in BGP, leaks happen every day, right? BGP is a very leaky protocol whereby in BGP, it's very common to see if I am this router, if someone sends me a route, I will automatically leak it out because BGP by default is a very, very permissive protocol, right? If I'm configuring 2 peers at the same time, as I'm configuring them, when I learn routes from one, it starts automatically leaking. So leak is not a problem. It's just that Telstra would have ended up becoming a free transit. But in this case, one of their edge routers or border routers are actually originating those. And this is where it's a big problem for me. The origin is AS1221, right? So something magical was happening in Telstra's network that time, right? And then again in July, right? One tiny network in the US is 10990. What did they manage to do? They again leaked out close to 200 more specifics. Again, you wouldn't see, you look at this, ideally you will see this as a /17, you will see this as a /15, you will see this as a /18 generally on BGP. But during the leak, they had automatically broken them into sub-aggregates, and then they had actually started originating those more specifics. Of course, they can claim that it was a mistake, right? It doesn't look like a mistake when you look at it, because a mistake would be if you leak it out and you become a free transit. But it doesn't look like a mistake when you actually take someone's prefix, split that into more specifics, and then start originating those out to the internet. Turns out they have a magic box, right? A BGP optimizer. I'm sure few networks in South Asia also use this kind of magic boxes, IRPs and others from Noxion and others, right? So please do not rely on this kind of BGP optimizer boxes to do your traffic engineering, right? BGP allows you to do very good traffic engineering. So use those techniques instead of relying on a magic box like IRP, okay? And again, in this case, it's very weird, right? AS1299, level 3, or they were claiming that they were actually doing route origin validation, right? This was an April Fool's attack this year. Again, people claim it was an accident. I don't know whether it's an accident or not, because this is very peculiar. Rostelecom has been involved in many hijacks in the past, right? And here too, during this incident early this year, what was happening was Rostelecom was learning the aggregates from all the CDN, major CDN providers. Again, for some reason, they were splitting those into more specifics, and then they were leaking those more specifics out to their peers. Rostelecom leaked it to its peer Rascom. Rascom feeds it to Cogent, and this is where things should have stopped, right? It seems what happened to Cogent's inbound filter, what happened to Cogent's outbound filter, what happened to level 3's inbound filter and level 3's outbound filter. If those big networks had very good BGP hygiene, we shouldn't have seen, the effect wouldn't have been that big. The problem comes when you have weird, bad BGP practicing networks like AS174 and others in the path. That's where you actually see that the impact of a route leak or a route hijack is propagated throughout the internet, right? If they stop it then and there, it wouldn't have propagated to the rest of the internet, right? Look at this. Look at the BGP replay. AS174, right? Cogent. It was pretty much Cogent who sent it out to the rest of the internet, and then who then kept propagating it beyond, right? All of a sudden, the best part to reach Facebook or Cloudflare or AWS is not directly to them. It is through Rostelecom, right? So they managed to divert traffic for some of the biggest networks or CDNs in the world. For what? I don't know. They claim it to be an accident. Sure, you can call it an accident. And BGP optimizer is not a new thing, right? This incident has been happening. People like Job Schneiders, they have been saying since 2017 not to rely on special boxes like BGP optimizers. Even last year, right? Last year, this happened. What was happening was Cloudflare was announcing a /20 to one of its upstream or peer, level 3. Because DQE, a regional provider in the States, their upstream was level 3, they learned that route through level 3, still /20, right? No problem. This is where the problem comes. When they start using a BGP optimizer box, right, where they actually started splitting this into 2/21s for whatever load balancing purposes within their own network, good, you are allowed to do that, but keep it within your AS domain, keep it within your AS boundary. What they did was their outbound filter was somehow broken. They leaked that 2/21s down to one of their downstreams, a tiny metallurgy company. And because this is not an ISP, imagine Cloudflare has hundreds of gigs of bandwidth, whereas you have this tiny network ATI, which has maybe a 1 gig of bandwidth, right? So you leak it down, right? They leaked it down to DQE, to ATI, 2/21s, fine. But what was weird was of course, their inbound filter, you can't blame their inbound filter, but what's weird is their outbound filter. They should not have send it out to their one more upstream, because ATI has two upstreams, right? You have level 3 on one side, a DQE on one side, you have Verizon on the other side. And this is a typical BGP route leak, right? This is what I was saying, that BGP by default is a very leaky protocol. Look at this. You have two eBGP sessions. As you receive that route from your neighbor, you do your best path selection. This too will automatically become best path, even though Verizon might be sending Cloudflare /20 this way to them. because it's a slash 20, whereas from DQE, they learn slash 21s, they would become the best path, and they leaked it out to their upstream. Their outbound filter wasn't in place. What happened to Verizon's inbound filter? Verizon learned it, accepted it as the best path, and leaked it out to the rest of the internet. All of a sudden, those of us sitting on the internet, for us, the best path to reach Cloudflare is not directly through Cloudflare, because even if I'm directly peering with Cloudflare, it's a slash 20 prefix that I'm learning route. Even if the second route, the leaked route I learn is a longer AS hop, I'll still take it because it's a slash 21. It's a more specific route, which means it's a better route than a slash 20. So even though I might have a direct peering with Cloudflare, I would still take the longer path to reach Cloudflare. So that's how Cloudflare lost about 15% of their global traffic, right? I will not talk about this. And this is Route 53. I really want to talk about this. I love this attack, right? These attackers, they managed to empty a cryptocurrency wallet without even having to touch someone's box, right? What did they do? They realized, oh, Amazon actually announces AWS for their whole infrastructure, AWS infrastructure. Let me change the color. For the whole of the AWS DNS infrastructure, AWS uses this slash 21 aggregate, right? This shows how big AWS infrastructure is. So this slash 21 is reserved purely for all the DNS infrastructure for all the AWS hosted services. What these two Russian networks did was they split this into 8 slash 24s, 2 raised to 3, and they started leaking that out, right? They started originating the more specifics. AWS originates the slash 21 as their Route 53 prefix. These two hijackers, they announce the more specifics. And again, watch out. They can only do so much damage because of the networks in between, right? AS6939, what are you doing here, right? They announced this hijacked route to all of their peers trying their luck. And then in the middle, you have networks like AS6939 who accepted those routes and propagated those routes, leaked it out to the rest of their peers. And HE has so many peers. And that's how the damage was done. But what was surprising with this attack was what? Was the attackers were not answering every DNS query that was coming to the AWS DNS infrastructure. Instead, they were just responding to queries related to myetherwallet.com. They will give you an answer that they want to give you, because pretty much if I control your DNS, I control what you see or what you don't see, right? So they would respond to queries related to myetherwallet.com. They would give you a response example, right? And that a response could be an IP address that they control, and they will pretty much redirect you to wherever they have it. And then, of course, what's weird was it's a combination of so many good security practices not being done, right? You can't just break into someone's cryptocurrency wallet, right? So people might have seen some weird HTTPS flagging, but they might have ignored those just to access their cryptocurrency wallet that time. And that's how, just because I could redirect you to a dummy site which looks like myetherwallet.com, I could then take control of your access credentials, and then I could empty your cryptocurrency wallet. So they managed to take close to about $18 million worth of cryptocurrency in about 2 hours, right? I generally jokingly call this the early retirement hijack, right? In 2 hours, if I can make $18 million, why not? Right? I'll not talk about this. And of course, the most famous one, right? 2008, Pakistan Telecom, somebody in the government had told them, hey, there is a video on YouTube which is against our belief. Make sure that it's not accessible. And I think the engineer did the right thing, right? What the engineer did was he null routed this slash 24 prefix. He forgot that YouTube at that time was a slash 22. He only thought it was a slash 24. He null routed it. He announced it to his upstream. And the problem is not just PTCL doing it. PTCL can null route it in their backbone, but they should not have advertised it out. So there was a problem in PTCL's outbound filter, but there was also a problem in PCCW's inbound filter, which is their upstream, right? So PTCL originated that slash 24 with a null route in their router, announced it to their upstream. Their upstream accepted that, and they propagated that to rest of the internet. Now me and you sitting on the internet, we look at those two routes, and I go like, all right, Google is announcing me a /22, PTCL is announcing me a /24, 24 is a better path, let me take that path. So for rest of us on the internet, the best path to reach YouTube was through Pakistan Telecom. And what do they have? They have a null route, right? It points to a black hole interface. They have a null route sitting there. All YouTube traffic was down for close to 2 hours globally, right? And I'm very thankful for this incident, because this incident kind of pushed the who is who of our BGP worlds, the likes of Steve Kent, the likes of Randy Bush, and others, to come together and come up with the draft RPKI framework, right? So all these headlines, and these are just few headlines, right? We can't even list how many BGP incidents happen daily, right? Have a look at BGP Stream, those of you who are interested. There are just too many BGP incidents happening on a daily basis. Why do we think these things are happening? Let's have a look at some fundamental concepts with regards to the whole internet. First one being the fact that no one is in charge, which is very good, right? No one is in charge. Internet is fully decentralized. Yes, nobody controls it. Not the US government, not the Chinese government, not the Russian government, right? Internet is run by every one of us who are a part of the internet. But the problem with that is what? The fact that no one runs it means there's no reference model. What do I mean? If I see the state of BGP table currently on my router sitting downstairs, and if I want to compare that view, I can't call up Tilina in, in Sri Lanka and say, hey, Tilina, how does your BGP table look like? Can I compare it with my table just to make sure that mine is correct or not? You can't. There is no reference point, right? There is no reference model against which you can compare what you see on the internet. I can't take my BGP table and look up a reference table. There is no reference table because no one runs the internet. If one single network was or organization was running the internet, of course there would be a standard table. They'll say, hey, the table should look like this today. Tomorrow it might look like this. They can at least give us a reference point, and we can compare our view of the internet against that trusted authority's view of the internet. But given the fact that internet is fully decentralized means we have no reference point to compare our view of the internet, right? Which means I don't know whether the BGP table I see is correct or not, right? The entries in the BGP table that I see. And the most important thing, everyone knows this, right? Routing works by rumor. Those of us who worked in the telco industry, telecom industry in the early days, during the voice times, everything was built in a point-to-point style, right? During the circuit switch days, if I needed to build a voice circuit from, let's say, Thimphu in the capital of Bhutan to Eastern Bhutan, I needed to build dedicated T1 or E1 circuits, which would only route calls to those places, right? So there was this concept of me building this point-to-point kind of network. But with the internet, there is no concept of a point-to-point. Internet will never scale, right? You can't build internet similar to that network where today maybe you have a user who says, oh, Tashi, I want to access traffic in Japan. Okay, fine, I build a point-to-point link to Japan. What if tomorrow a second user says, hey, how about US? I want to access content in US. Can I build a second link to US? A third link to some country, a fourth link, fifth link, sixth link? So we cannot scale with that point-to-point style of building a network. That's why we have the internet, wherein I advertise my network to you, you do your best path selection, you advertise your best paths to your neighbor, so on and on and on and on. We don't have to be directly connected. Not every network on the internet needs to be directly connected, right? And then through that model of me telling you my network information, you whispering that to your neighbor, and your neighbor, eventually every one of us on the internet, we know how to reach each other, right? But we do that with an assumption that everyone in the middle shares my information correctly and honestly, right? And you saw in the middle, the few examples that I showed you, in the middle, some people were not being honest. They took a /20 announcement, split it into two /21s. You have already changed the information that I originally told you, right? In a typical face-to-face classroom setting, I normally say, I whisper to someone in front of the class and say, hey, I'm Tashi from Bhutan. Whisper that, whisper that. Somebody in the middle wants to be funny, and he might say, Tashi is from Japan, right? And by the time I ask this person sitting right here at this side, hey, what did you hear? He goes, Tashi is from Japan, right? So such things happen on the internet because someone in the middle can be dodgy. Someone in the middle can not be honest, right? That's where most of the incidents happen. So that's a major problem because routing works by rumor. I assume that everyone in the middle will speak the truth, which is not the case. So how do I know when I receive routes in my BGP table, how do I know if the person who originated the network that originated that network is the true owner of that prefix? I can't. I can't make that out. Right? Routing is variable. Again, this goes back to the first point that I was talking about. Because there is no reference point on the internet, my view of the internet depends on where I am on the internet, right? Few of my friends here, Tilina, Asela, and others sitting in Sri Lanka, when you look at your BGP table, you see, yes, those are the same routes or the same prefixes, but the path that it takes to reach you is very different to the view I have if I look at my router sitting here in Brisbane, right? So my view of the internet depends on where I am on the internet, which means what? Which means, again, I cannot compare my local view with your view. I can't just call up Tilina and say, can I verify my local view looks the same as yours or not? Because they don't look the same, which means how do I know what is wrong or what is right on my routing table? It's very difficult to know that, right? And of course, everyone knows this, right? Routing works in reverse. Before you can send me traffic, I need to tell you my network, you tell me your network, and then we exchange traffic, right? When I announce a network to you, I'm telling you that, hey, this network is reachable through me, send any packet for this destinations to me. You do the same. You announce your network information to me, right? Which in a way is indicating to me that, hey, Tashi, if you have any packets for this destination sitting behind me, send it to you, right? The fact that routing works in reverse, where we do network announcement one direction, we receive traffic the other direction, that means I can take advantage of this fact. I could announce my competition's prefix, example, Dave. Let's say Dave works for Telstra, I work for Vocus here in Australia. If I want to hijack Dave's prefix, I could go like, all right, let me announce Dave's routes, more specifics. If he's announcing, let's say, /16s, I announce maybe /18s of his prefix to the rest of the world. The moment I do that, traffic that was supposed to go to Dave now ends up coming to me. This is how we reroute traffic, or this is how we hijack traffic, right? Hijacking a route is not the big deal. The fact that you hijack route means you're able to reroute traffic that was supposed to go somewhere to you is a major problem, right? And it's purely because fundamentally routing works in reverse. And as a final joke, anybody read this RFC? RFC 3514? Professor Steve Bellovin from Columbia University. One of the April Fools, he wrote this RFC, which basically says, hey, security is becoming really difficult. Those of you who are bad people out there, please turn on your evil bit in your packet header so that when I receive that packet, I look at the evil bit, oh, this is a bad packet, drop it, right? So he wrote a very funny RFC. But jokes aside, Professor Steve Bellovin's humor aside, there is no evil bit. Or is there one? If you guys know an evil bit, please let me know, right? Then life would become much easy. How do I know whether a BGP update that I receive is a good or a bad BGP update? I don't know. It looks the same, right? So it's very, very difficult for us to identify what is bad. That's why if you look at all the frameworks that we have when it comes to security, look at DNSSEC, look at TLS, look at SSL, look at RPKI, right? What do we try to do? We try to identify what is good, or we at least try to approximate what is good. And it's purely because it's very difficult to identify what is bad, no evil bit, which means all the security frameworks we have, it tries to approximate and say, hey, this is good. Anything outside of this is bad. Is pretty much what all the security frameworks that we have do. You look at your digital certificates, that's what it does, right? It binds your identity or something to your public key and saying that if it's outside of this, it's not him, right? So we try to approximate good as this. Anything outside of that sphere, we say it's bad. And you have to trust that, and then you drop the bad things, right? And why should we worry? It's just too easy. You saw the examples, right? So what can we do? All those examples that I gave, even without RPKA framework, you could have stopped that. You could have stopped that by relying on basic fundamental BGP hygiene that we talk about, right? Do not trust anyone. Inbound filters with your customers, with your peers, with your upstream. Yes, don't allow bogans. You can't filter granular with your upstream, right? But you can granularly filter your peers. You can granularly filter your downstream customers, right? Apply prefix filters. Don't allow them to send you 1 million routes. Apply a prefix limit, right? If someone has a /19, allow them to deaggregate up to /24. This is what, 2 raised to 5, which is about 32/24 plus maybe aggregate and a sub-aggregate. So I might allow up to 50 prefixes from that peer who has a /19. Anything outside of this, they might be leaking someone's route to me. So at least if I have a limit, it would prevent all those route leaks that we saw earlier. Please do AS path filters. If you have big peers who have lots of downstream customers, please do AS path filter. Please apply a AS path limit. Do not blindly accept weird AS path attributes that you see in routes, right? How deep is the internet? Anyone in the chat? How deep is the internet? Oh, did something happen to my slides?
Yeah, your slides just stopped.
Nope, okay, it's back. Any questions in the chat or in the document?
Nothing yet.
Okay, cool, thank you. How deep is the internet, anyone? Give a guess. Maybe not, let me give a guess. According to Jeff Houston, the internet is about 6 or 7 AS hops deep, right? It's about 6 or 7 AS hops deep. That means sometimes if you look at a BGP table, sometimes I see this weird 50, 60 long AS path attribute, some cases 120 something AS prepended routes that I receive. Right? The problem with those kind of dodgy AS path attributes or any BGP attribute is whenever you store those routes, once you've done your best path selection, you not only store the route, you also need to store the attributes, right, in your memory. It costs you money. So why do we make internet more expensive? Because of somebody's bad habit. So you can actually apply a AS path limit too, right? And the most important of all, RFC 8212. Remember what I said, BGP is a very, very leaky protocol. If this is me, if this is my upstream, 1, this is my upstream 2, I have eBGP going on with them. As I'm configuring, as I'm bringing up these 2 eBGP sessions and as I'm making changes to them, as my upstream 2 keeps announcing its routes to me, I do my best path selection without me telling BGP what to do. It keeps leaking those things out to my other eBGP peer, right? BGP works like that by design. BGP is very, very, I need to change my pen color. BGP is very, very leaky and permissive by that concept. What RFC 8212 now wants to do is, can we change the default behavior of BGP from a permit to a reject or a deny? What does that mean? That means, in a summarized manner, what RFC 8212 is trying to do is, RFC 8212 is trying to say, BGP is not allowed to accept a route if there is no explicit inbound filter. BGP is not allowed to announce a route if there is no explicit outbound filter. Meaning what? If there is no explicit filter inbound or outbound applied, BGP should not accept or announce routes, okay? So that will prevent all the route leaks that we see on the internet, okay? If everyone starts doing RFC 8212. What it says is, do not accept routes if there is no explicit inbound filter. Do not announce routes if there is no explicit outbound filter. But sadly, not every platform, every vendor platform supports RFC 8212. So those of you who are commercially paying some vendors for your boxes, please force them. Tell them, hey, your box needs to be RFC 8212 compliant. And in case you don't have that, because some boxes might be too old, you still can do RFC 8212 style of configuration, where you first shut down the BGP session, configure your filters, apply your inbound, outbound filters, and then you bring up the BGP session, right? It still does the job, right?
Tashi, we have a question in chat.
Oh, yes.
Is it enough to just filter without signing ROA or implementing RPKI?
Yes, Mel, if you actually follow a good habit, I'll talk about it. That's a good question, right? So what I'm trying to say is RPKI is not the final solution. It's not the elixir, right? It's not your ultimate pill which will stop all the bad incidents in BGP. RPKI alone cannot do it. I'll talk about those, why RPKI alone cannot do it. We need to mix our traditional techniques, add one more layer where I'm now using a digital certificate-based, digital signature-based RPKI framework. And on top of that, you still need to keep adding other things, because as I talk about RPKI, you will realize it at the moment can only do so much. It needs to do this much, right? Mel, I hope that helps. So with that, let's have a look at, before we jump into RPKI, let's have a look at currently what are the tools and techniques that we use, right? Somebody sends you an inbound peering request or a transit. Somebody wants to buy transit service from you or wants to peer with you. What do we normally do? We do what's called the legitimacy of address check. Okay. You need to make sure that that network who wants to peer with you or wants to buy transit from you, they will tell you, right? Hey, this is my AS, this is my V4 prefix, this is my V6. I would like to peer with you. Or they could say, I would like to buy transit from you. You can't blindly accept those, right? You need to do a legitimacy of address check, right? Currently, there are a couple of techniques to do that. Either you look up a WHOIS database manually, or you rely on RPSL tools or IRR databases to look at people's routing intent. Once you've verified those, then you go ahead and craft your inbound filters, right? You craft your outbound filters, then only you bring up the BGP session. This assumes that every engineer does that. Not many networks do this, right? Oh, somebody wants to buy transit from me, money talks, let me just blindly accept whatever routes they send me. We shouldn't be doing that, right? So what are some of the legitimacy of address check tools? First is look up your WHOIS database manually, right? Good thing about the numbers world compared to the names world, there are only that many internet registries, right? How many RIRs globally? Only 5 of us, right? Some RIRs have their own NIRs or sub-delegations, but suffice to say that right at the top, there are only 5 regional internet registries who delegate this address space to people, V4 or V6 or ASNs, right? That means it's easy for me to go and check those authoritative databases, right? Why am I saying authoritative? Because no one can create an entry in APNIX database unless it is you, right? Your credentials are, you are authenticated. Then only can you go and create those entries. Where there are those junk databases where I can pretty much go create an account and then I can create any entries. But in an authoritative database like APNIX WHOIS or RIPES WHOIS or any of the registries WHOIS, you can, example, I'm looking up this prefix here, right? 202.125.96.0. I look at it and I go, all right, there is an INET num for this, which indicates to me that it was indeed delegated by APNIC to us. Who was it delegated to? It was delegated to APNIC Training, Asia Pacific, right? And within that, I can also find a route object sitting there for this. What is a route object, by the way? A route object is nothing concrete. It's nothing authoritative either. It's just a routing intent that I put there, okay? Me as owner of this network, APNIC Training example, I could describe my intent in a IRR object like your route object here. For V4, for V6, we have what's called a route 6 object, right? It is nothing but my intent, me telling the world that, hey, this /24 prefix is mine. I plan to originate this using this ASN. So I express my intent in a database using a route object there, right? And I'll show you how other people can then consume this, how other networks can then look up these things and they can actually consume to automatically craft or generate their inbound filters, okay? Second one, which I'm seeing in developed parts of the world, is this concept of a letter of authority. I don't like this. I don't recommend either. It provides me no security. It's zero security. It's just that if things go wrong, I'm not responsible, right? I'm not even going to spend time here. The second option, either you look up the WHOIS database manually, or you then look up the Internet Routing Registry. Many of us have experience whenever we want to buy transit from NTT or level 3 or someone, they'll say, hey, can you please go ahead and create your route 6 objects or your AS set objects in any of these IRR databases. The most common Internet Routing Registry database is the RADB database. It comes from the Merit Networks, the early days of the internet, right? Problem with RADB, it's dirty, it's junk, full of junk. Even I am responsible for some of those junk. I have created route objects in RADB, which I have now forgotten to delete. I have left Bhutan Telecom, and those routes are still sitting there in those databases, right? The idea of Internet Routing Registry database or a IRR database is it allows me to express my intentions. How do I plan to route this particular prefix, V4 or V6? How do I intend to route them? And what is my BGP policy or relationship with my peers or with my upstreams or with my downstreams? I can express those things in an IRR database. Example, to your left, you will see here is a typical route object. I'm doing a WHOIS lookup, pointing it to RADB, and I'm saying, hey, tell me what record do you have about this prefix 6145.248/24, and you will see two interesting things. You will see two route objects for the same entry, right? One route object was created by us in APNIX database, which says this 248.0/24 prefix, I plan to originate it out of AS 135533, right? On the other side, you see Vocus has also gone ahead and created this in RADB directly. Normally, Vocus shouldn't have to create this because whatever is created in authoritative databases like APNIX database, it would automatically get mirrored or synced to RADB. Okay, so there is no need for Vocus to go ahead and create this second route object that they created. So Vocus has gone ahead and said, all right, this one will be originated from this. Lucky at the moment, my origin AS and Vocus's origin AS, they at the moment do not clash. What if this said AS 17821? Right? Then these are two conflicting entries. Which of those two entries do I trust? Which of those two entries do I know is correct? So that is the biggest problem with the Internet Routing Registry. First thing, you can have more than one entry that are conflicting. If there is a conflict, which entry is correct? Which one do I pick? Do I pick AS 17821 as the origin, or do I pick AS 135533 as the origin? So there is no way for you to authoritatively check that or verify that, right? And within RADB, you can also define your policies, your import policies, your export policies. For my inbound, what are my BGP policies that I have defined for that peer or for that upstream or for that downstream customers? What's my outbound export policy? What's my outbound BGP policy when I announce routes to them? These days, people do not consume Otnum objects. They would generally consume your route objects, your route 6 objects, and they would consume your AS set object. Okay, and I'll show you a quick example how they. So here is a quick example. Now, remember what I said. An IRR database is where you can express your intention on how you plan to route a specific address space, V4 or V6. And how do networks globally consume that? Networks globally consume that by looking at that database, IRR database, and saying anything in that database I will accept. Anything outside of that database I will not accept. Does that make sense? So when they generate their inbound filters, anything, all your route objects or route 6 objects, if they are sitting in the IRR database, they will accept those routes. But if you accidentally miss out some route or route 6 objects from those IRR database, they will not accept those routes. Okay, so that's how you generally, how people generally consume the IRR database or IRR objects. So let me quickly show you. Let me do this. I'm trying to demo something. So if you look at the slide, right? Currently, if you look at the slide, you will see that I'm trying to generate a few. Here is an example of how people would auto-generate their filters. I'm using a RPSL tool called BGPQ3 here, right? In the old days, we had RTconfig, which was a part of the IRR toolset. And RTconfig wasn't as lightweight as BGPQ3. BGPQ3 is very lightweight. So in the first example here, what am I trying to do? I'm trying to auto-generate a prefix filter for what operating system? For the bird operating system. Let me change my pen color to red. So as you can see, what I'm saying is I want to automatically generate a filter for my peer, which is AS17660, which is my former network Bhutan Telecom. I have a bird router, so I'm saying B, right? L is the name of the prefix list. So I'm saying, hey, BGPQ3, I want to auto-generate a prefix filter for this peer, and it automatically points to RADB. Remember that. All RPSL tools will generally point to RADB. So here is my V4. So these are the route objects that I see in RADB for this particular network. So it automatically generates that V4 prefix filter. If I want for V6, I just need to give the keyword 6 here, and then I will generate those prefix filters specific to that particular peer. But in the second example, I'm using the same command, but now I have added a few extra filter here. What I'm saying is, yes, point it to RADB, but remember what I mentioned? I mentioned that the WHOIS databases that all the RIRs maintain, RIPE and ARIN and your LACNIC and your AFRINIC and others, they automatically get mirrored to RADB. So what I'm saying is, hey, BGPQ3, still point to RADB, but I only want entries that got mirrored from APNIC as the source. Does that make sense? Only those authoritative objects that you receive from the APNIC WHOIS database, I want only that. And look at this. Now I see only 4 routes in the APNIC database, but you see on RADB, how many route objects do I see, right? So think about that, right? So you need to be very careful. And that's why those of you who run networks, whenever your upstreams or your peers tell you to create route objects in IRR database, please do not create them in all those wacky, dirty databases. There are about 23 to 24 IRR databases. Every big operator runs a IRR database. Do not create it there. Create it in the APNIC WHOIS database. It's authoritative. Only you can create. I can't log in into my APNIC and create route object for you. It won't allow me. I can't even type a wrong IP address because APNIC system will know what was delegated to me. It won't allow me to create those. But I can go to RADB, $100 or $150. I can get a maintainer object and I can create any route object I want. So be very careful if you want to consume IRR database using RPSL tools. Make sure that you specify authoritative source. Example, if this peer is from Europe, you could say source RIPE. If this peer is in America, you could say source ARIN or source AFRINIC, but point it to authoritative source, okay? On the rightmost side, if your peer has lots of downstream networks, then you can also use BGPQ3 to generate AS path filters by using your AS set object, okay? In this case, I'm saying, hey, BGPQ3, I want you to generate an AS path filter for me for this particular network, AS17660, and please use this AS set object. And this 3 says, please use 4-byte ASNs also. And that's why you will see that it automatically crafts this AS path filters. Second example gives you a better appreciation of how you can consume AS set object. Example, if you have someone like Superloop, who is a very big network in Australia, I can't do prefix filter granularly because it could be 1,000 lines. Instead, I want to generate an AS path filter. And BGPQ3 by default will give you a Cisco syntax. You can see these are all Cisco syntax until you specify you want Juniper or you want Bird, okay? So here, Cisco syntax, you can see I'm picking up super loops AS set, AS super loop, and I'm then generating all these AS path filters of all these downstreams. This network, or this network, or this network, or this network, allow them to prepend and coming through AS38195, I'll accept them. So that's how people generally consume IRR objects, right? So those are the two well-known techniques we have at the moment when it comes to us doing a legitimacy of address check, right? Either we look up the WHOIS database manually, confirm that, crafts your filters manually, or you can ask your peers or your downstream customers to create their route objects or their AS set objects or route 6 objects, and then you automate your filter generation. So if you point it to authoritative database, no problem, consume that filter. But if you don't point it to authoritative database and you point to RADB, I can't even trust the filter that I generate, right? So I've already mentioned some of the problems with IRR databases, right? First thing, they are not authoritative. Second thing, there are just too many of them. What if you find an entry in one IRR database, but when you look up rr.entity.net, which is entities IRR database, if I don't see an entry there, which one is correct? Is that IRR database correct or this correct? You don't know which one is correct. Even on the same database, if you find more than one entry for the same route, which one do I trust? Is the first one correct? Is the second one correct? Is the third one correct? So it's very, very difficult to do things with IRR if you are not careful, okay? So with that, let's go back to basics. Remember what I said earlier, everything we try to do in security is, because it's difficult for us to identify what is bad, we always try to identify what is good, right? So the idea here being, for RPKI, we looked at current techniques. They are not authoritative techniques. You cannot for sure validate anything that I see in a route object in an IRR database. How do I know whether you created it or somebody created it? So how do we authoritatively and confidently are we able to confirm that, hey, did this network allow that network to originate that on their behalf? How do we do that? That's where the question that people like Randy Bush and Steve Kent and others on the internet, they thought was, can we borrow things from PKI, right? Can we borrow things or not? So what they were saying was, can we use digital signatures to convey authority to use? But before that, let's jump back to basics. Everyone comfortable with concepts of asymmetric encryption or PKI? Let's do a quick recap, right? First things first, you have your typical symmetric encryption, you have your typical asymmetric encryption, right? So what's symmetric encryption? Do you guys want me to do it, or will somebody help me out here? Nobody will help me out. I will continue to do that. Let me just change the color to green. So with symmetric encryption, I'll keep it very short and straight. With symmetric encryption, you have a common key. You are the sender. Someone is the receiver. You want to send a data to someone. You encrypt that with your common key. You get a jumbled up thing which no one can make sense. Send it across. He will use that same key to get the original data back, right? So that's symmetric encryption. Pretty easy, single key, very less work with regards to crypto. But the problem with symmetric encryption is the concept of key explosion, wherein if I'm talking to Dave, I need one key. If I'm talking to Thelina, I need a separate key, because if I use the same key, then Dave can listen to what Thelina and I'm talking, right? So that's the problem. If you talk to 1 million other people, you need 1 million keys that you need to manage. Hence why people rely on asymmetric encryption, right? What is asymmetric encryption? Well, with asymmetric encryption, you have two keys. You have a public key and you have a private key, mathematically linked. How, what details, you go read it. No time for that here, right? So you have a key pair. I'll get some water. You have your typical sender. And let me change the color of the receiver. Pen color receiver. Let me pick magenta. Receiver. The receiver also has a public key. The receiver also has a private key. All right. So When the sender wants to send a packet across to the receiver, right, there are many ways you can make use or consume this. All right. First, if I want to send a packet across to the receiver and I want the receiver only to know who I am or authenticate me, what do I do? What do I do? I can sign that with my private key, right? And I'll get up this weird jumbled up text. My receiver will, what will it do? Will pull my public key from the public key server, right? It'll use that, my public key, to get the original document back. If they can do that, the fact that I signed it with my private key, this is my private, my public, this is my receiver's public, this is my receiver's private. The fact that I signed it with my private key, which means it can only be decrypted using my public key, is a confirmation to the receiver that it was me indeed, Tashi indeed, who sent that document. So that's how you do authentication, right? Or you could do one more thing where you want to do authentication. Plus, if there are monkeys in the middle, man in the middle, who capture those packets and try to make sense of it, let me also add some confidentiality bit to it. So I can do double encryption on top of that, right? So what I would do is, what can I do? I could take the original document, right? I could take the original document. I can sign that using the receiver's public key, to get a jumbled up text. And I then encrypt that further using my private key to get a double jumbled up text, which I send it to the receiver. The receiver receives that, and then the receiver will do two things just to verify who I am. Okay, what color do I use? Black. Right. So what the receiver will do is it'll take this first double encrypted packet. Since it was encrypted using my private key in the outer layer, it'll pull my public key. It'll decrypt it with my public key to get this text. It gets this text, right? So that's the first layer done. That proves that it was indeed Tashi who sent it, because I signed it with my private key, and my private key is only with me. It's supposed to be unique to me, my private key. Public key, I make it public. Private key, I keep it private, like everything else, right? So that second encryption, since I had encrypted it using the receiver's public key, now the receiver will use his private key to get the original document back, this document back, right? So that's how you can make use of asymmetric encryption in many different ways. So first example was just to authenticate who the sender was. Second example is a combination of authentication plus encryption, right? So that confidentiality, so that other people, monkeys in the middle, cannot decipher or make sense of what I said, right? So that was the basics of asymmetric encryption. So for PKI, public key infrastructure, we rely heavily on asymmetric encryption. How do we do that? So public key cryptography is PK, and I is nothing but infra. Infra means what? I need to build what's called a chain of trust, right? Example, in the previous example, you saw that I can encrypt things with my private key. Somebody can pull my public key to decrypt that, right? But anyone can pull my public key, not just you, not just the receiver. So how do you for sure know that that public key is indeed me, right? So for that reason, we need to build what's called the chain of trust. Trust needs to start somewhere, and then based on that framework, we need to then validate things up the chain of trust. How do we do that, right? So typically you have your root certificate authorities, your DigiCerts, your IdenTrust, your Symantec, and other. Sometimes they could have what's called the intermediate certificate authorities in the middle, or they could directly be issuing an entity certificates, right? If you have intermediate certificate authorities, then they could further issue end entity certificates, all right? That's how you build a chain of trust. But what do I mean by this chain of trust? All right, again, changing my color. So generally, when you look at a digital certificate, when you look inside a digital certificate, what do you see? Let's use the X.509 framework. What do you have inside a digital certificate? If you actually look at any of the digital certificates sitting in your browser at the moment, you will see a couple of things. You will see many things, but most importantly, you will see your public key being associated to an identity, example, for your TLS or SSL, right? You have this document. This document then gets signed by either the intermediate certificate or the root certificate authorities. It gets signed by the root certificate authorities private key. Does that make sense? And this gives me a signature, this weird looking signature. So when you browse a website, let's say you're browsing google.com. When you browse google.com, Google's web server will give you its digital certificate. And that digital certificate will have what? That digital certificate will have this certificate, right? Google will give me back a certificate plus the signature, right? It'll send me the certificate plus the signature. I receive it. So what do? I have received this and I have received this too. To decrypt the signature, what do I need? Remember, this signature was signed by the root's private key. So the root's public key will be sitting in your browsers by default. If you look at all the root certificate authorities in your browser, you will see that you already have the root certificate authorities public key in your certificate. So you will take the root certificate authorities public key and you will try to decrypt this signature, and you should get this original blob back where you have that binding information between the subject's public key plus the subject's identity, or it could be a domain, in this case, google.com. Okay. So once you have decrypted this, you compare this with what you see here. If they look okay, then you have actually verified google.com's public key up the chain of trust. In the old days, Google used to have an intermediate certificate. Google used to rely on IdenTrust or DigiTrust. And then there was a Google ICA. And then there was all of the Google services. One single Google ICA for their Google services, many different services, YouTube, Gmail, google.com, all their websites, all being signed by one single. So what happens is the root CA will sign Google's intermediate certificate authorities public key. The intermediate certificate authority will then sign the public keys of YouTube, public keys of Gmail, public keys of google.com. And whenever I browse this web server for google.com, I will receive two certificates. I'll receive one certificate which was signed by Google ICA binding google.com's public key with google.com, the domain. And the second certificate I'll receive is the root CA signing Google's public key. So you will see those two certificates. So whenever you decrypt something, you need to verify that that public key belongs to that organization, and you have to go up the chain of trust for that. Okay? So that is the question that this slide is asking you. Can we use digital signatures to convey that authority? Right? So borrowing from whatever we discussed so far, so we discussed about PKI, right? The unique thing about PKI is you are trying to authenticate, right? As you can see in TLS or SSL, right? What you try to do is you're trying to authenticate. You're saying, hey, is that public key associated to that domain, example, that domain. But with our PKI, R, which stands for resource, right? We modify the X.509 framework, whereby I can now create a binding between your public key plus your IPv4 resources or your IPv6 resources, in some case, even your ASN, right? That binding information, right? Your public key bound to the resource that has been delegated to you. So this is what we call a resource certificate. With RPKI, your registries like APNIC, right? Whenever, example, Sri Lanka Telecom, SLT, whenever SLT gets a /19 prefix example, You need to turn on your RPKI engine, yes, on RPKI port on the My APNIC portal, which means you are generating your key pair, public key and private key, plus you're also requesting APNIC to issue you a resource certificate. This is what we mean by a resource certificate. Whenever we delegate an address, whatever V4 or V6 resources and ASN that have been delegated, along with that, the public key that you generated, we bind that, and this gets totally signed using APNIC's private key as the root. APNIC is the root. It gets signed by APNIC's private key, right? So you have your resource certificate plus that signature sitting here, which means since now your public key is verified, you can then go ahead and use your private key. You can use your private key to sign anything you want, sign pretty much anything you want, right? Because your public key is verified up to the root, up to APNIC, because APNIC issued that resource certificate to you, meaning we bind your public key to your V4 or V6 or ASN resources, and we also digitally sign that, right? So that is your validation, that's your proof up the chain of trust. That means now that your public key is verified, you can use your private key to sign anything. From a routing point of view, what do we sign? From a routing point of view, using your private key, what could you sign? From a routing point of view, you could sign your origin. You could say, hey, 202.144.128.0/19, up to a max length of, let's say, up to /24. I plan to originate that from AS 17660. You sign that using your private key, right? And that is what we call a ROA, a route origin authority, because you have digitally signed this using your private key, right? And this whole signed object that we just created is what we mean by ROA, a route origin authority. You are saying me as the owner of this prefix, because my private key and my public key are associated with this. The fact that APNIC has signed your public key is binding with your resource proves to the world that whoever holds the private key is the legitimate owner of that resource, okay? So using that authority, now you are saying that, hey, I'm the owner of this prefix. Based on that authority, I nominate this network AS 17660 to originate this route, a /19 route, up to deaggregate up to /24. I nominate this network to advertise that to the internet on my behalf. Sign it with your private key. That becomes your ROA, okay? When somebody sees this ROA, how do they know it is you, right? So they will take your ROA. They know that you have signed it with your private key. So how do they decrypt it? They need to pull your public key. How do they pull your public key? Remember that resource certificate that APNIC issued? So APNIC publishes not only the ROAs to the repository, APNIC also publishes all the resource certificates we issue and all the signatures we issue, along with CRLs in your manifest files and others. But let's keep it simple here. So resource certificate already has your public key. So whoever wants to consume this ROA needs to pull that resource certificate so that it can pull your public key, use your public key to decrypt this, and then they will see that signed authority, right? But how do they trust your public key, right? They will look at the resource certificate. It was signed by APNIC. So you end up with a chain of trust. You end up with a chain of trust you end up with a chain of trust like this, right? If you had created a ROA and I am a validator sitting somewhere on the internet, I consume the ROA. For me to decrypt this ROA, I need your public key. For your public key, then I need to go talk to the RPKI repository where APNIC publishes your ROAs plus your resource certificates. I pull them all down. I need your public key now to decrypt this ROA. So what do? I see that in the resource certificate. I use that to decrypt. I see a signature which says you have authorized this. And then I verify this up the chain of trust because I know that that authority, that resource certificate has APNIC's private key signature there. APNIC has signed it using its private key. That's how, so every validator does that. A validator will pull all the ROAs down, all the resource certificates down, and will validate each and every ROA up the chain of trust. could be from LACNIC, could be from BRIBE, could be from the Afrinic region, could be from ARIN region. Because if I'm trying to filter the whole internet against RPKI or ROAs, I pull the whole world's ROA, I validate each and every ROAs up the chain of trust. And those that I validated becomes what's called the validated ROA payload. All right. So that's pretty much the RPKI framework. Any questions? All these long things are for you to read. I have tried to keep it very short. I have already gone up to this. So this is a typical ROA. You assign, you as the owner of that prefix, you say, hey, I authorize this prefix up to this max length to be originated by this. And if I'm multi-homing, if AS17821 could be my one upstream, let's say I don't want to originate things myself, I want my ISP to originate, you can create a second ROA for this same prefix. You can create a second ROA which says 176.32.019 up to a max length 24. I nominate is 45192. So I can have multiple ROAs for the same prefix. It depends on what kind of a network connection or network design I have. All right. So that is a very condensed crash course style of RPKI framework. Try to simplify it. All right. So with that, what can RPKI do? Now that you can authoritatively check or validate whether someone is allowed to originate a route or not, RPKI can definitely help us prevent any origin hijacks, misorigination. Sometimes instead of me typing 17821, I might type 17281 accidentally, right? It might look like a hijack because it's a wrong AS. I can prevent that, okay? Or I can prevent your fat finger, generally wrong typos, okay? So current form of RPKI, currently the most well-known use of RPKI is to do origin validation. Origin validation. I can verify which network is allowed to originate that particular V4 or V6 route onto the internet, okay? Some components in the RPKI framework, issuing party is your internet registries. These are your CAs, certificate authorities, okay, who issue the resource certificates whenever they delegate an IPv4 or a V6 resource to you. They also issue a resource certificate with which you can now create ROA. And then that CA is supposed to publish your ROAs plus your resource certificates plus other things to global repository, right? That's how whenever you create ROA in my APNIC portal, every 10 minutes, APNIC pushes it up to a global RPKI repository. Then you have what's called the relying party, which are nothing but your validators, RPKI validator, right? Whose job is to do what? You have your global repository here, 5 RIRs, pull from all of them, pull all the ROAs, pull all the resource certificates, pull all the CRL files, pull all the manifest files, verify each one of them up the chain of trust, and then produce a validated ROA payload. Verify each and every ROA. That's what our RPKI validator is supposed to do, right? It'll pull all those either through a rsync or a RRDP protocol, verify each one of those ROAs up the chain of trust, and then it'll finally do a crypto removed version of a cache. It'll generate a plain text list which says this origin, this prefix length, this max length, this origin AS. It'll produce that list. So cryptography stops here. After this, so good thing about route origin validation is cryptography is not on the router. Cryptography is all done by this relying party tool, which is an RPKI validator. That's why our routers are not expensive to do that. Okay, couple of models. Predominantly, everything is a hosted model where APNIC or your CA is responsible for all the CA functions. Delegate resources, along with that, generate the resource certificate, along with that, do all key management, maintain all those certificate validity, keep publishing them on a timely manner. All those things are done by your CA. Some networks prefer to do their own delegated model, right? Example, within APNIC, you have NIRs, JPNIC, TWNIC, CNNIC, IDNIC, you have in India, you have IRIN. I don't want to even mention them here, KRNIC and others, because they don't do RPKI. So let me not mention them. JPNIC does it, TWNIC does it, CNNIC does it in a broken manner, IDNIC does it, right? So in those cases, they become our intermediate CAs, right? So APNIC delegates a big chunk of address space to them. For that, APNIC issues a resource certificate using that, which signs or binds their public key to those big chunk of resources. Then whenever they sub-delegate those down to their members in their countries, they can issue um, resource certificates, because those resource certificates that are issued to this um, NIRs, as we call them, National Internet Registries, they are CA capable certificates. So they are allowed to generate resource certificates and issue it down. So it takes that, it is taking that model of a root to an intermediate certificate authority down to an end entity, right? Okay, let's not waste our time here. Now, with all this that we have discussed, let's have a look at BGP. You look at this route, what do you see? You look at this and you go like, all right, I am learning this particular route, 24066400/48. It is originated by AS17821, comes through 5550551 before it reaches me. And I can see that in the AS path attribute, right? But what if someone naughty who is closer to me from my AS hop count originates the same route, hijacks the same route? The prefix matches, the prefix length matches, but because they are shorter to me, right? AS hop count wise. So which one would become the better path of these two? BGP by default would pick a shorter AS path as the best path. So the hijack path becomes my best path. This does not become the best path. So my traffic gets rerouted to that baby attacker there, right? But let's now bring in the RPKI framework. When I bring in the RPKI framework, what happens? Remember, I said that there is a global RPKI repository where we publish all our ROAs. You deploy your validator, right? Validator's job is to pull all those ROAs from the global repository, validate each one of them. Okay, cryptography stops here. Okay, now once it has verified each and every one of ROA, it maintains a ROA cache in its memory, crypto removed version, which says, hey, this prefix length /32 up to a max length of /48, I see a origin AS of 17821. Your validator feeds that to your router over RTR protocol, and your router maintains it in its memory, a cache, RPKI cache in its memory. Now what happens is, whenever you receive a BGP update message from your eBGP peers, the router will not blindly accept it. The router will say, hey, hold on, let me verify. Okay, this route, prefix matches, prefix length /48 matches, origin AS matches. Cool, let me mark it as valid. How about this route? Prefix matches, prefix length matches, but the origin AS is 6552. The ROA says it should be 17821. This is not valid, right? So that's how route origin validation works. And that's how we use ROAs, we consume ROAs to filter our inbound BGP updates. All right? So what is valid? Prefix matches, prefix length matches, origin AS matches. That route is called valid. Okay, what is invalid? The prefix could match, your prefix could match, but the origin AS could be wrong. Someone is trying to hijack, someone is trying to originate your more specifics, or the prefix could be correct, but your prefix length may not be correct. Meaning you might be announcing as an owner /19, but me as an attacker, I might be announcing a /24. Right? So prefix length may not match, that's also invalid. Then sadly, you have the third state called the unknown state or the not found state, which is typically 75% of the current internet is not found. Not found means what? When I am doing this, example, if I receive a route which is 2001 db8 : /32, if I receive it, if the router receives it, when I look at the ROA cache, okay, I received the BGP update, I look up my ROA cache, hey, I can't find a ROA to compare that against. So I say, I don't know, or not found, okay? So not found is you receive a BGP update message. When you look up the ROA database, you can't find a ROA corresponding to that particular prefix. So your BGP router goes, I don't know, unknown. And it's because people have not created their ROAs. Okay, Sri Lanka, there is quite a bit of unknown from Sri Lanka too, right? SLT especially. Okay, I'll show you at the end. So before I wrap this up, I want to do a quick demo. So before I wrap this up, let's play this game. So have a look at the ROA. The ROA is what? 65420, prefix is 10.0.0/16, max length is 18, right? Now let's have a look at, you are a router, that ROA is sitting there, you are a router, you're receiving your BGP update. You receive this first. You receive this BGP update. Prefix is 10.0.0.0/16. Your ASN is 65420. Is it valid, invalid, or not found? Can someone please type in your Q&A or raise your hand? Is it valid, invalid, or not found? Anuradha, valid. Why is it valid? That's a good point, Anuradha. You're right. It's valid. Why is it valid? Help me out. Why is it valid? The prefix matches, prefix length matches, origin AS matches, so it is valid. Thank you. Thanks, Anuradha. That's fine. Second one. How about the second one? Second prefix 10.0.0, 10.0.128.0/17. Mohammed Rifnaz. What is no? No means not found. Why is it not found? Mohammed Rifnaz. Invalid. Why is it invalid, Mohammed? Good, good, please. Why is it invalid? Okay, let's check. Let's check. Look at the prefix 10.0.128.0. Hey, /17. 10.0.0/16 up to a /18. 128.0 is a part of this prefix within 16 to 18 range. So 17, the prefix looks valid, length looks valid. What's the origin is? It matches, so it is also valid. Yes, Naveen, valid with the max range of /18. You're correct. How about the next one? Let's go quickly. Next one, 10.0.0./16. Prefix matches, prefix length matches. Look at the origin AS. Does it match? Not valid. Correct, Anuradha, because the origin AS doesn't match. Correct, Naveen. How about the next one? 10.0.10.0/24. Amir. Why not valid, Amir? Amir, why is it invalid? Look at the prefix, Amir. Length, correct. Correct, correct. So 10.0.10.0, hey, look at the prefix length. Look at the max length. Origin AS matches, yes, but the prefix length doesn't match. That is invalid. How about this last one? 10.0.0.0/8, origin AS 65430. Valid, invalid, or not found? Anuradha, invalid. Great. Anuradha, first I'll give you the chance. Why is it invalid? I'll give the chance to Amir. Amir, why is it not found? Amir, you said not found. Why is it not found? So let's have a look at the prefix. Okay, prefix looks good. Look at the prefix length. This covers only 16 to 18. This says /8. There is no reference ROA for me to compare this prefix. Okay, so I can't even compare it. So your routers would generally go, I don't know, not found, because there is no reference ROA for this. Okay, so what can you do? Let's say you have created your ROA. First step, you have created ROA for your own prefix. You have deployed RPKI validators, relying party softwares. Now you want to start doing route origin validation on your routers. Okay, you have enabled them. What do you do with this validation states? You can do a few things. If you are upstream, or if you are a route server at an internet exchange, maybe you don't want, your customers don't want you to drop things for them. In that case, you can just tag the validation states. I've just given a typical old style community tag. where for valid, you can pick this value. For not found, you pick 1. I'm going with RFC. And for invalid, you pick a value of 2. You can tag them, send it to your downstreams, right? You can tag them, send it to your downstreams, and then your downstreams, could then act on it based on that. Maybe they want to accept valid and not found. Maybe they want to drop invalid. So all they need to do is match your community and start dropping it, right? Or you could go with the old recommendation. This was a recommendation that was 5 or 6 years old, where in the early days of RPKI, nobody was confident enough to tell you to drop invalid. So that time we said, play with preference values, local preference values. Give your valid the highest preference values, not found a medium preference, and your invalid the lowest preference, okay? Or these days, I say drop your invalids. Do it. Out of the 86,000, 87, 870,000 routes, IPv4 routes, about 6,000 are invalid. About 90,000, for close to 90,000 IPv6 routes, about 2,000 or 3,000 of those V6 routes are invalid. Drop it, but don't drop it blindly, right? If I'm still running a network, I'll profile my network and make sure that there are no flows or good traffic going to those invalid destinations, right? If there are traffic going to those invalid destinations, check whether you have valid or not found paths as a backup path to those invalid paths. Yes, Telina?
Yeah, Tashi, we just have only 5 minutes.
Cool, no worries. Right? Does that make sense? So profile your network. If there are flows going to that invalid destinations, and if there are backup paths which are valid or not found, go ahead, drop that invalid because you have alternate paths. But if you have flows, heavy flows going to those destinations invalid, and there are no backup paths, better pick up the phone and talk to them and tell them, right? Hey guys, I'm planning to do RPKI. I'll be dropping route origin. I'll be dropping invalids. Let me help you correct those invalids, right? So I'm not going to discuss AS path or anything. Let me instead directly jump to the last slide. And the last slide being here, Sri Lanka focus. And this is where I want everyone to. So this is before lunch today, I tried to look up this. So in Sri Lanka, what do we see? Not found. 27 of those are not found. 27 from Apinix resource, from Apinix address space range. Let me just change the color. So what do I see here? From Apinix delegated prefixes in v4, 27 of the routes from Sri Lanka are invalid, 9 of ARIN delegated address space invalid, and from RIPE 1. And who are those networks? Hutchison. If there is anyone in this room from Hutchison, please create your ROAs. What are you waiting for? For stars to align, or please create. You have the maximum number of not found, 16 from this AS, 4 from this AS. SLT International. I saw some SLT folks here. 10 of your routes coming out of 9329 have no ROAs, and so on and on, right? But good that it's still less than it's about 40 routes that we see from Sri Lanka that does not have a valid ROA, and that does not have a corresponding ROA. But let's look at invalids. So that's the not found. Please, can I request this 1, 2, 3, 4, 5, 6, 7, 8? Can I request Telina through LKNOG? I would like this networks to please create ROAs. If you create it, Sri Lanka is 100% ROA coverage. If this networks actually create ROAs for those prefixes. Now let's have a look at the invalid one. We see 15 v4 routes originated by SLT having invalid tags. And those are fixable invalids, Agasela and team. Those are invalids due to max length, 15, all 15 of them. I see that you have created a ROA for your /19 prefix. So your ROA prefix length is /19, your max length is /19, but your actual BGP announcement is 1/23 oh, sorry, and 1/23 and 14/24s. So you are announcing more specifics in BGP, but your ROA covers only up to /19. Please make sure when you create your ROA matches your BGP announcement, right? If you do that, we will have no invalids from Sri Lanka, right? So that's pretty much it from me, Telina. I was hoping that we could do some demo, but no time. So that's it, Telina. Thank you so much.
Thanks, Tashi. So thanks actually, Tashi and Dave both. So they were behind this screen helping Tashi. So since we are running scheduled timing, if you have any other questions, you can put them on the Q&A session, and then we will put them offline to Tashi. Next, it's going to be on ManRS by Asela. So Asela is kind of a founding member of LKNOG and currently is heading SLT services as the general manager. So he's kind of having 20 years of experience around many things. And now these days he's looking after information security area. So Asela, it's your time. Asela.
Give me a second, Tilina.
Yeah, sure.
Good morning, everyone. Still, we are at 11:30. Can you all hear me?
Yeah, Sela, we can hear you.
Okay. So I'll immediately I'll put my video on for you guys to see me. I think, can you see me?
Yeah, we can see you.
Yeah. Okay. And I will now start sharing my slide deck. Right. Can you see the slide?
Yeah.
Okay. Good morning, guys, again. And after a very informative and very technical session from Tashi with lots of hands-on details, I'm actually coming back to more basics on internet routing security. So I think you got the introduction of me from Tilina. I'm working for Sri Lanka Telecom PLC, and I'm looking after information security domain, as well as I'm now working for Sri Lanka Telecom Services, which is a SI arm of Sri Lanka Telecom PLC. So we are here to talk about the basics of securing your internet routing system based on the manners framework. You can see MANRS, we call it manners, though it doesn't actually grammatically is not correct, but we call it manners in the routing domain. So we'll jump to the next slide. Well, to start the session, to introduce, internet is a network built on collaboration and trust, as Tashi also explained. It is all about trust and collaboration between the operators. That is how the internet works. So securing the routing system is very essential for the foundation of a stable internet, right? So, so this session is here to emphasize the importance of security in our routing systems in order to secure our own networks as well as making the internet more stable, and discuss quite a standard approach which all the network operators can adopt easily to secure our routing system and ultimately the internet. So we are targeting the audience ISP operators, service providers, and internet transit providers, carriers, large network operators with own ASNs, internet exchange operators, and all network engineers at large, and planning engineers, and the LKNOG community who might not be actually working for a service provider, but who are thirsty for knowledge in the internet domain, right? So I'll start with the question now. When it comes to information and network security, do you think of for your companies, and do you have a corporate information security framework? This is a very easy question to ask. Of course, you will put all your thumbs up and with a grin. Yeah, you all might have an information security framework in your companies, but the second question, how many of you have considered securing the routing system as part of that framework? Especially the ISPs and the large networks. How many of you have included that in your information security framework? Well, when it comes to that question, I think you will have a little bit of a doubt. The face on this slide will show that, right? You might not be, as for my experience, it is not included in some of the information security network frameworks of service providers. So here what we are trying to do, if you have the have an answer of yes for the question 2, of course, this will help you to improve your knowledge and maybe grab something new. And if it is no for the question 2, let's answer for a little bit more questions. And why is it not part of your framework? Can routing really impact security? What damage can it do? And how best can we protect our networks? So that is what we are going to cover in a very tight schedule, 30 minutes, a framework to protect our networks from routing security. So why do we need to secure routing? When I started, I told you. So secure routing is essential for a stable internet. Without, because it is the BGP that we know is very leaky. Tashi explained how it is leaky. And it is mostly built on trust of the peering parties. And there are new technologies where you can actually technically handle how the trust. And nowadays, if you look at all the events happening in the internet, not a single day goes by without an incident destabilizing the internet. Okay, so if you look at the major threats, what we have for the internet security, routing security, first one, route hijacking. I think Tashi explained what route hijacking is. And then route leaks, second one, the major threats. And third one is IP address spoofing, where you actually masquerade or pretend to be someone else. And what does it impact? It could become a DDoS attack. It could inspect somebody's traffic by rerouting it to a rogue network, or you could lose your revenues, or you could lose your credentials, or Bitcoins can be stolen. In Tashi's examples, he showed that there was an 18 million Bitcoin theft happening. So he called it a very nice name, retirement hacking, right? And then reputational damage mostly is very damaging for a service provider or a carrier. So these incidents are very global in scale, and with one single operator's mistake, it could actually cascade towards the internet and then do a lot of damage. So the three threats that we have for the internet routing system, I explained earlier: route hijacking, route leaks, and spoofing. We'll go and see what these are basically, because Tashi explained in very detail, but in very high level, I'll just go through how route hijacking is. Now, if you see this network, very simple network, you can see if ASNQ customer wants to access the server ASN A2 at the bottom, he will take this normal route, because it is the A/24 prefix is being advertised properly through the internet, and he has a clean route. But what if there's another network, a rogue network, the red one, who advertises this same prefix without authorization, and we call it a hijack. It propagates through the network. Usually this should not happen if all the networks have their proper protections. But if it happens, this ASNQ's traffic could get a wrong route and go to the rogue network, the red network, and get lost or stolen, and the packets will be lost in that network, and the server A will not have access from the ASNQ. So this is basically what route hijack is. I hope that you understand basically what route hijack is. So that is the threat number one. Okay, so the motives will be, sometimes it is a mistake, typing mistake, or a configuration mistake, or maybe a deliberate hijack to steal some coins or credentials, or attack a network. And the symptoms that we see when route hijack happens is that there could be increased latencies in the network reaching another network, and there could be networks becoming unreachable, and tracers go through very unusual routes, and networks lose access from parts of the internet. So these are the symptoms that we see in networks when a route hijack happens. So to detect this, unfortunately, BGP hijacking can be difficult to detect, as one of the prefixes is unable to detect the hijack themselves. Only thing that we can do to use some external services to listen to these BGP prefix announcements, and then have some anomaly detection over there. So with a lot of ASNs around the world, it is very hard to actually, it is very easy to fly under the radar undetected. So if you see these incidents, Tashi explained the Pakistan YouTube incident very clearly. Starting from that, there had been so many incidents happening in the internet until very recently. Also, there have been many attacks, many hijacks happening. So I'm not going into detail to these incidents, but there are thousands of incidents happening, and every day, every week, there is some hijack happening in the internet. And one of the very recent hijacking incident, I'm putting it here in the high level, where the Brazilian AS Fibra Plus announcing a prefix owned by Taiwan NIC, and then the next transit provider also advertising it out without filtering, and then the Taiwan NIC losing its connectivity for a few minutes actually, but this is, I put it here because it's a very recent incident. And then we go to the other one, the second threat that we have, the route leaking. It's quite similar to hijacking, only difference being that route hijacking is happening on the, not on the multi-home networks or the customer end network, but it is happening on the transit level networks. But when multi-home network, which is in red here, is advertising a route which it received from upstream, it is advertising it back to another upstream. This is called a leak. You see the difference between a hijack and a leak, because ASN B should not advertise something it received from upstream to another upstream. Then what happens, if you see the red arrow here, ASN B becomes a transit provider for ASN X1, right? this should not happen, because you are a customer of X1. X1's traffic upwards should not go through A's and B, right? I hope you get it. So what happens now with X1's traffic going through A's and B, all its routes or the routes, the links gets congested, because A's and B's is carrying transit traffic on behalf of another transit provider, which should not happen. So now the A's and B's the links will be congested, and he will totally go out of operation, because he cannot bear the traffic, right? So this is a route leak, and if you see get the motives, mostly it is this happens because of mistakes and bad banners, and symptoms: bad routes, unusual increase of traffic on the peering links, and interface congestion. It will immediately congest your links, and your internet will be totally down. And detect, you need to you will get alerts on overloads on the interfaces, unusual peering behavior detection, and then sudden changes of route paths and change alerts. So recent incident 2019 for this leaking, you can see Safehost, which is a Swiss data customer, announcing a prefix from to China Telecom, which it doesn't own, and it becomes a leak, right? This is a very recent incident where the Safehost is announcing wrong prefixes, and it becomes a leak. So third threat that we have is spoofing, which is essentially hiding or pretending to be somebody else. And you see in these two images, there could be reflection attacks or impersonation attacks, where the victim could be the endpoint or the middle point. So what the attack is doing is he's actually spoofing an IP as a source IP and sending it to a router or the network, and the network, without checking, passes it over to the victim. Or then what happens is, if you do not check whether the attacker's IP is correct from the point of entry, this goes through and then damages the networks and the endpoints. So this is the third threat that we have. So, and when it comes to spoofing geography, now you see the map where the red areas are very dangerous things happening in the world, and then yellow and then green. Sri Lanka, fortunately, is quite safe, one of the green, dark green sites, where we are actually quite good in anti-spoofing. If you see, we have only one count of blocks spoofing incidents, and then it is much better than some other developed countries even. So what do we need to do to manage these threats or protect our networks is to mind our routing manners. What manners means is mutually agreed norms for routing security, which is an Internet Society promoted mechanism. It's a global initiative supported by the Internet Society that provides crucial fixes and very simple framework for all the service providers to protect their networks. So we'll go through what manners says and the framework that it is introduced into the network operators to adopt as a framework. There are 4 simple but very concrete actions proposed by the manners framework. I'm putting it in a bit of a different order than where the manners framework is announcing it. I put coordination first, where the coordination means where you have all the contact information of the operators and the network administrators announced globally.
Hasela. Okay, everyone. So it seems like Asela got dropped for a few minutes. Let's wait for him to reconnect. Yeah, Asela, you may reconnect. We can see you, but can't hear you.
Can you hear you? Can you hear me now?
Yeah, now we can hear you.
Okay, where did we get dropped?
No. You can start with Manas.
Okay, did we go through the point 1 coordination?
You can go with again point 1.
Yeah. So point 1 coordination, what it means is that we need to maintain our contact information, the network operators contact information, for everybody to see the contact information globally, right? And then global validation, which means how we can validate the objects that we announce about routing objects that we have. Tashi explained how we can use the ROA and the RPKI infrastructure. That is what global validation means, where you are publishing your information in a standard way in RIRs, IRRs, and then everybody can validate what is owned by you. And the third point is route filtering, where we ensure the correctness of our announcements to the adjacent networks, where we announce only our own prefixes and our customers' prefixes without making a mistake. And then anti-spoofing is to stop anybody from pretending to be somebody else, where we only announce the own end users or infrastructure prefixes into the network. Okay, these are the 4 manners actions that we have in the framework. There are 4: coordination, validation, filtering, and spoofing. These are the 4 actions that we need to take. Very simple. So the first 3, coordination, validation, and route filtering, they are used to prevent these hijacking and leaking activity. And anti-spoofing, obviously, to prevent IP spoofing from happening. So there are 3 threats and 4 actions that we need to take in the manners framework. So in a nutshell, this is my concept. I propose to use this following 1, 2, 3, 4 model to remember the concept. What I need to do in this short session is to put a framework into the minds of the network operator engineers, where our target, which is 1, is for secure routing. And our objectives is to secure our networks and stabilize the internet. There are 2 objectives. And there are 3 threats: hijacking, leaking, and spoofing. And we have 4 actions to take based on the manners framework. These are coordination, validation, filtering, and spoofing. So remember this: 1, 2, 3, 4. One is for secure routing, that is our target. Our objectives are to secure our networks and the internet. 2 objectives. 3 threats: hijacking, leaking, spoofing. 4 actions to prevent those threats from damaging our networks. That is to coordinate, validate, filter, and anti-spoof. Okay, I think you can now remember the framework. So we'll now go to the what are these actions? 4 actions: coordinate, validate, filter, and spoofing, anti-spoofing. Coordination is I explained in brief, where we are advertising. The operators needs are advertised to maintain their contact data in common places such as peering DB or RIRs, whois databases, or RADB or RIPE, and also on their public website. It is recommended as an additional help to advertise on your, even on your public website. At least you have to advertise in one of these databases. That is the manners requirement. So this contact information should include operators' current point of contact, information for the NOC, the NOC contact information, and information of their ASN, all net blocks, domain names. Additional information is also welcome, such as the routing policy in an IRR, and contact information on public web pages, and so on. So these are additional but not necessary. That is coordination. And if you see an example now, the current point of contact advertised by the ASN SLT Global, this is how it looks like, right? And when you advertise this information, you have this admin C and tech C objects, where it has all the information of the contact person's name, the email address, and the phone numbers, right? So therefore, anybody who wants to contact this network administrator or technical contact, they can contact our Kaushalya at slt.com.lk or the given phone number, and then get it verified. That is the purpose of this coordination activity, action. So the second action, there are 4 actions: coordinate, validate, and then filter, this is the second activity, where you actually validate the objects using different mechanisms. Now, we as network operators have to maintain following data in the databases in the IRRs. The auto number object, and then the route object, and a set object, and the ROAS. So this was in detail discussed by Tashi in his presentation. So I think you have a basic idea what these things are. And there are 2 ways of doing this. One is through IRRs, and the more advanced method is for using RPKI, using the public key infrastructure for resources of internet routing resources. So through IRRs, what you do, IRRs contain information submitted and maintained by ISPs or other entities about ASN routing prefixes. IRRs can be used by ISPs to develop routing plans, because it is publicly available and authorized by an IRR. You can use them to build your routing policies. And then there are some other third-party IRRs like NTT or RADB. I think there are some confusions whether RADB should be used because there are some junk routes also advertised there. But however, these are the available options. And the second method that they are proposing under the manners is using the RPKI, the public key infrastructure mechanism, using the private public keys. And then what it does is, it is very clearly explained by Tashi. We have this route origin authorization, and we need to note that these do not include your customer announcements, but only prefixes that belong to your ASN. Only the origin ASN is verified under this ROA, and not the full path. So that was clearly explained by Tashi. And all regional internet registries offer so-called hosted resource certification service. Like Appinix does a very good service for that. And then we can go to the validate examples. Now, if you see Sri Lanka Telecom origin, the route object validation in Appinix, it appears like this. And in RADB also, it is appearing with the same AS and the same route 6 prefix. So this is what route object looks like. And then the autonomous number object looks like the one on the right-hand side. So I'm just putting it for examples what objects look like on the databases, on the RIRs or IRRs. And these are some examples of Sri Lanka Telecom, some objects of Sri Lanka Telecom prefixes. And the fourth action that we need to take under manners, 1, 2, 3, 4, is anti-spoofing. So for anti-spoofing, we need to filter as close as to the packet's origin as possible. So that is the best practice, and filter all invalid source addresses and filter precisely as possible. So how you can do this is through access lists, packet filters, permit valid source and drop any, or and also there are on all the routing platforms, you have the unicast reverse path forwarding check, where you forward the packets only if there's a valid return path to the network that you are allowing the packets to enter. You only forward them if you only have a reverse path available on the router to return it back. Okay, otherwise you do not send the packet through. So these are the two mechanisms basically what the network engineers can use to stop spoofing from happening. So to become a manners participant, what the network operators have to do is to agree to the principles, first one, and then implement at least one of the 4 actions. What are the 4 actions? You remember 1, 2, 3, 4. The 4 actions, you have to implement at least one action out of the 4, but not only coordination. So coordination alone, complying to coordination alone will not do, but the remaining 3, you have to implement one of those to become manners compliant, right? So if you are manners compliant, you can go to this manners website, manners.org, and use the if you comply to these requirements, you can get the manners badge and advertise it on your website, and also be listed in the manners web. And also you can, as the manners web says, you can contribute to the manners framework documents. So ultimately, what I need to deliver under this presentation is for you to remember what manners is. The framework I have given is 1, 2, 3, 4. Secure routing, secure network and stable internet, threats, hijacking, leaking, spoofing, and the manners actions, 4 actions: coordinate, validate, filter, and anti-spoofing. So next time when we meet, I hope that some of our network operators will become manners participants or manners compliant, and we will see some badges appearing on our network operators websites, right? That is our target. At least few of us will have the badge. And this is a very good tool for us to use for our network security. The first question I asked, whether you are actually incorporating your within your information security framework, whether you are incorporating the routing security as part of it. So that is usually no as a question, as an answer when I ask, and I know by experience. So please, network engineers, be serious and implement this so that we can protect our networks as well as the internet as a whole. So I sign off, Tirena. Thank you for giving me the opportunity, and within a very short time, give you guys a brief of what routing security and how we can implement it in service providers. Thank you so much.
Okay, thanks, Asela. And is there any questions for Asela? Since we are almost at the lunch, you can put the questions in Q&A and we will pass it to Asela so he can answer you offline. So as Tashi requested and as Asela described, I would like to ask you all operators here at least to put your ROAS and then to try to come up with your manners and get complied. So if you need any kind of a help regarding these, you may contact any of us in the LKNOG committee, and then we are very much happy to help you. Okay, so it's lunchtime, and before that, I just want to remind our sponsors, our local sponsor, SLT, Sri Lanka Telecom PLC. So they were like with us from the beginning of the LKNOG, supporting us. And then the AWS, our international partner, Amazon Web Services. So they were like helping us from the financially, and then need to mention Epinik for providing us the Zoom platform. Okay, so thank you all to all these sponsors, and now it's the lunchtime, and we'll be hosting the webinar, and we'll be back in another 2 hours time, exactly 2 p.m. Sri Lanka time, and then we'll be meeting you again for a few more other presentations. See you at 2 p.m.
2 p.m.
2 p.m. Yeah.
Hello, everyone. Can you all hear me?
Yes, Jivanti, please continue.
Okay, let's start. Okay, good afternoon, everyone. Welcome to the second session of LKNOG4 conference. First, let me introduce myself. I'm Jivanti Hettiarachchi from Buddhist and Pali University of Sri Lanka and also an executive committee member of Lanka Network Operators Group. It's my pleasure to be a moderator for this session on LKNOG4 conference. In this session, we have 4 presentations lined up. We have 30 minutes allocated for each speaker. So get ready with your notepads because this is going to be a very interesting session and informative session for you. So while listening, if you have any questions, please add them into the Q&A box down here. Selected questions will be answered by the speaker at the end of the presentation. Let me introduce Kaushalya, the first speaker of this session. Kaushalya is from Sri Lanka Telecom, has more than 10 years of experience on SLT Global Network and IX operation as a peering administrator. Also, he is the secretary of the LKNOG. Today, Kaushalya is going to talk about insight of SLT IX operation and the current status. Ladies and gentlemen, please welcome Kaushalya. Kaushalya, have you joined in with us?
Hope you hear me. Yeah.
Yes, we can hear you.
Yeah.
Kaushalya,
thank you. Yeah. Okay. Thank you, Jivanti. So, of course, good afternoon, friends. But my video is not working, so bear with me. But I will rush through the slides. So, hope you will. Do you see the slides?
not yet, Kaushalya. Yes, we can see your screen.
Yeah. Thank you very much for giving me the opportunity. Let me now let's move on to the connectivity side now, which we do on the security side in the morning. So this is actually the Sri Lanka Sri Lanka Telecom Internet Exchange. So that is the update which I am going to present. So let me recall what makes us to set up an internet exchange called SLTIX. So as you know now, we have in Sri Lanka, we have a couple of, not couple of, actually around 10 internet service providers around the country serving to 20 million the population. So let's say now a customer, end user from Sri Lanka Telecom wants to access a website which has been hosted in Dialog Network. So for that, if there's no any interconnection between two service providers, so the particular end use of SLT, so he has to first come into the SLT, the main concentration point. I'll maybe a router. So from that end, the SLT has to look for where the dialog, the hosted website is. So if there's no interconnection, SLT has to put it into the service providers, the global service providers. That means we have to send the request of the end user to the global internet. From global internet, that the service provider of SLT, he has to find where the dialogue connection is. From there, he has to traverse the request of the SLT end user to the dialogue website. So it will take let's say 50, 60 milliseconds. Sometimes if it goes to Europe or US, it will go around 100 milliseconds. So that is what if this type of interconnection not available within Sri Lanka. So that will be the vice versa. Maybe for all these the customers, on local customers, they have to they will not have improved performance due to this unwarranted latency. So within Sri Lanka, as you know, all the networks, we will be able to traverse all these the packets within 10 millisecond range. So this is the point for SLT-IX. That is why we have set up this to improve the end user experience of all the local internet users. So maybe Dialog, maybe Mobitel, maybe SLT, maybe Lanka Bell, local the Tata, Airtel. So all these registered ISPs, their end users will get within 10 milliseconds, let's say within 10 minutes, sometimes maybe within 5 milliseconds, the packet traversing since due to the support of this internet exchange. So that is the main point. The other point, which is also supportive, that is actually the expensiveness of the upstreams, especially since Sri Lanka is an island. So we have to depend on the cables, the CMEV, BBG, the flag like cables coming to Sri Lanka from Europe, Singapore, and India to get these internet connections. So this is a big investment, and the service providers are also expensive. So if this setup is not here, so we'll have to depend on the cables and these the global service providers like NTT, Level 3, or Tata, Airtel, Sintel, like the global players to traverse all these packets, which is originated from Sri Lanka, and the target is also at Sri Lanka. So that is the point where this SLT-IX plays a pivotal role. So the other one is and with that we will maintain the carrier neutrality, which I cover in another slide. As I told you, our motive is to keep local traffic local. So that is the prime objective. And with this, having this setup, having this SLT-IX setup, we are gaining some experience, which is unique, as now we are most of time we are actually serving customers. Now with this setup, we are actually facilitating the members, not like customers. So that is what the experience which we are gaining. So let's move on to the next slide. So this the local exchange. This is all these local ISPs are eligible members. So as I told you, SLT acts as the facilitator, and this SLT-IX, we have a autonomous system number, different unique autonomous system number, and a different address space provided by AppNIC. Then we are actually facilitating the public peering and selective peering or private peering as well. So that is actually, let me come on to the peering. Peering means now if two networks are willing to have an internet, the network connectivity, so that is called peering. So these days, the technology side, the peering means the BGP peering. So border gateway protocol, that is the protocol the widely used by peering administrators to have these the network information exchange and the packet exchange. So that is the kind of peering which I am referring. So public peering means in this internet exchange, we have two route servers to distribute the prefixes which support the packet traversing. So if you are setting up a BGP session with a route server, that is called public peering in internet exchanges. If you are having setting up a peering with one party or a group of parties, that is called selective peering or private peering. So that is what selective peering and public peering. So and we have another opening. So if you have if a network party is having some added services to offer like DNS or looking glass, which may be important for all the members, so we are open for that. And this is the network topology.
There's a question from Anuradha Udravana. He's asking, is SLT-IX the only IX operating in Sri Lanka?
Of course, now there are two kind of internet exchanges. This is layer 2 exchange. This is the standard setup. If we consider layer 2 setup, this is the only exchange at Sri Lanka. But there's another internet exchange, that is LISPA, facilitated by Lanka.com. That is actually a layer 3 kind of exchange. It is actually looks like BGP with their own AS number. So there are technically two things. So only layer 2 exchange we have. So there's a layer 3 exchange, that is LISPA. I think I have.
Yes. Thank you, Kaushalya.
Yeah. So this is the network topology. Now, as you told you, now we have a layer 2 switch, and our autonomous system number is 131.173, and we have two route servers. So those are small routers, and I'll show you all these connected internet service providers. And there's a special kind of member, that is iRoute server provider NetNode. So they are European provider. Why we have let him join? That is, he is providing us iRoute server facility. So that is why he is there. That is, and you see the Tata, SLT Net, so Lanka Bell, Mobitel, Learn and Dialog. So all are interconnected. So with this setup, as I told you, if a SLT customer wants to get connectivity to Dialog network, so with this SLT-IX layer 2 switch, so he can access within Colombo, and he will get the return as well through the layer 2 switch. So this is the technical arrangement. So we have layer 2 and layer 3, 10G and 1G ports. The port. So that is the network topology. So we'll move on to the next one. So basic requirements. So that is, as I told you, the ISP, the member should have ISP license from Sri Lanka and from the Sri Lankan government. And the other one is they should have ASN and the IP address space on their own. And we have agreement and peering policy, which should be signed by all the members. So all these the connected parties, they have agreed for this agreement and the peering policy. And like I told you, this net node, similar to net node, if there are any other the facility provider for the internet industry of Sri Lanka, so we are willing to get them into the platform. So what we offer to the members. So as I told you now, this is actually now kind of the member society. So that is why we are keep on telling members. So this is we are offering a layer 2 ports, maybe 1G or 10G, based on their traffic volume at annual fee. And there's a user guide for how to connect and how to get it tested. There are some security concerns. We are getting them done. Then we will connect onto the live network. So all these things are mentioned in these user guides. And this is our IPv address space. That is /22 space. So once you get this IP port, we will issue 1 or 2 IP addresses for you based on your the number of ports you are requesting. So we will, and we have IPv6 address space also. And the other difference is, now even though we have AS131173, so you don't see on the BGP the path. So that is actually this route server configuration. That's a special configuration. With that configuration, you will not see the route server ASN. You will feel you are getting directly the routes from the originator. So that means if I am at SLT, so I am getting Lanka Bell prefix just with their ASN, not in between this AS131173. So you will not see 131173 anywhere in the internet or wherever the networks. You will not see on BGP 131173. So that is what this special kind of configuration. So there's another one, iRoute server directly connected. And we have at SLT, we are running a 24/7 network operation center. So we will looking after the platform and the ports with that service. So you can at any time you can call. So all these the guidelines we have issued, and we have the profile of port usage. And by the end of this year, so we have an upgrade project. So we have just completed that. So with that, actually we are giving 10G ports. Recently we should get 2-3 the members upgraded onto 10G platforms, so with their adequate traffic. And we move on to the carrier neutral data center at PTPN. That is why I promise you to told the carrier neutrality means now this data center at PTPN, you can now you can get the access path on your own. So it does not make any restriction for you to select SLT backbone. So if you come on to some other network, so you are free to come. So it's just at the within a cross connection away, our port or the platform is there. So once you come on your own, you can have the cross connection. Then we will connect with our port, our platform. So we will offer 1G or 10G port. So that is what now this carrier neutrality. So earlier setup, we had the switches at SLT headquarters. They are actually we have our own only our own network present. So with that new setup, we have built up the carrier neutrality as well. And the other one, so we have set up a backup platform as well. So if you need, if you have any redundancy requirement, so we will be able to give you another 10G port, which is from a different switch, and we can issue a different another IP, so that so both will be operational. So one is if one is have a problem, so you will have uninterrupted service with the next one, so that we can provide. So with all those the member traffic, so we are coming on to 3 Gbps now with this the COVID-19 environment, the pandemic situation. So we see actually a lot of the traffic, mostly the education, and there are some office traffic. So I hope so there are more growth as well with most of the people are working at home. So if there are a lot of websites hosted, website hosting within Sri Lanka, definitely the IX has the big future. So that is what we expect. So within few months time, we are targeting to have a member portal with more information, so that all members have a look with more information, and route servers also to be upgraded. So in return, actually, I told you that we are expecting more traffic, so that end user experience will be improved if we can have websites hosted in Sri Lanka, maybe in Sri Lankan data centers. And if the end path, I mean the access paths, have much more the bandwidth and the quality, so we'll have definite the future for this internet exchange as well. So with that, actually, and we are targeting few 1 or 2 local ISPs. So they also will come, I suppose. And with all these things, as SLT staff who are facilitating this, so we are going to have gain experience on maintaining an exchange for the benefit of all the local internet industry, the community. So that is what I can share with you. So if there's any
Yes,
questions.
Kaushalya, there's another question from Anuradha. He's asking who is connected to ILSPA, LISPA.
Actually now we as SLT, we are member of LISPA. We invited Lankacom to join with our this SLTIX. So that is we invited them. We are waiting for them. We already actually joined with LISPA, but LISPA and the SLTIX we cannot join. Join actually now it's not,
Kaushalya?
yeah.
Actually, what Anurad is asking is, who are the members of LISPA? What are the peering parties in LISPA?
LISPA actually now it is
How many ISVs are appearing at the LISPA?
LISPA actually I have limited information. Actually, that is that is on LISPA we are a member only, not like SLTIX. I think most of local ISPs they have joined LISPA as well.
Okay.
Can I just add something to this, especially for Anuradha's question? Now, LISPA was the initially first, it was formed as an association, Lanka Internet Service Providers Association, and the facility was hosted in Lankacom, and all the ISPs were paying a membership and maintaining that, layer 3 internet exchange point. And earlier and after that SLT, we actually started the IX in somewhere around, I think 2000, I can't remember actually.
2015.
Yeah, because we wanted to. This is actually done not as a profit with a profit motive, but more of a internet community facilitating, not for profit basis. We are doing this for the national interest, and this hosted in a layer 2 environment, as Kaushal explained. So these are the two exchanges, and most of the ISPs are present. Only thing, with the growth of the traffic and 10G requirements and all that, we need to go to a layer 2 high capacity exchange, and it's good to have redundancy always. So LISPA is there, and a redundant is major capacity facilities here with SLT.
Thank you, Asela. Thank you, Asela, for your comment. And Kaushali, there's another question. Are there any websites for SLTIX and LISPA? From
of course, yeah, of course, LISPA and SLTIX, two different things. Let me explain that in that way, because SLT, we are only a member of LISPA, so that is entirely different from this one. So for this, actually in 2021, in our the target, with them having a member portal, so we are targeting to have a website for SLTIX. So with that, actually now all these the global internet exchanges, so we are also planning to have a member portal, and with more information and like traffic and the port and the other member information. So we will have it. Let's have it on the next year. So that is what we plan.
I think there are some more questions coming up, but I think Kaushalya can answer it after the session also. So thank you, Kaushalya. Thank you very much for your informative presentation on SLTIX operation. Let's move to our next presentation then. Thank you, Kaushalya.
Okay, thank you. Bye.
Yes. Our second presenter is Champika Vijayatunga. Champika works for ICANN as the Technical Engagement Manager for Asia's Pacific. Prior to ICANN, he served as a Training Unit Manager at APNIC. Champika was instrumental in forming LKNOG and served as our founder president. He also serves in various other technical community groups and committees. Champika is speaking on cybersecurity dimensions in telecom industry. I warmly invite Champika to deliver his speech. Champika, over to you.
Yeah, thanks, Jivantik. Can you hear me well?
Yes, we can
Yeah,
hear you.
I think that's a little mistake on the topic. My topic is going to be on universal acceptance and
Sorry.
email address internationalization. I think the next speaker is going to talk
Yes.
about the cybersecurity aspects. Yeah.
Universal acceptance and email address international.
Okay, let me share my screen.
Yes, we can see it, Kaushal. Champika.
Okay, let me also actually get my video. Hope you can see me as well.
Yes, yes, we can see you.
Okay, and so as I said again, I'm going to actually talk about universal acceptance and email address internationalization. To some of you, I think these two terms can be a bit new, right? But in case if anyone is sort of new to this whole concept, I will have some introduction as well, so that you are aware of what the context is. Now, first of all, we have this term called universal acceptance, or in fact, to say it is universal acceptance readiness, basically, right? So you can see the vision here. The vision is that all domain names and email addresses should work in all software applications. Now, to give a sort of background context, as you know, obviously, like, we use DNS all the time. Domain names, right? It is an unique identifier. Now, most of us, like mostly, we use domain names in English characters, or basically Latin-based characters. And but the thing is, over the period of time, there have been a lot of changes in the DNS ecosystem, and also there have been several new top-level domains have come, and so on. So we have to actually analyze and see whether our software is ready to accept this change. And also even software, the search engines, the browsers, and all that, right? So basically the software can adopt to this whole change. So that is the context that we are talking about, right? Now, to give you a little bit of background of the evolution of DNS, I have kind of, separated it into few eras. One is, of course, pre-2009. That was basically, the DNS was designed in the early 1980s. And since then, if I take, that whole period, pre-2009, now we have these generic top-level domains, or simply what we call GTLDs. So these generic top-level domains are the ones that, like .com, .net, and .edu, and so on, like the top-level domains, basically, right? And then, like in early 2000s, we also saw that some new top-level domains came, like .aero, .travel, and so on, right? Now, earlier ones were like 3-character ones. They were limited to 3 characters, like .com, .net, and so on. But like in early 2000s, this was even further extended, more than 3 characters. And also at the same time, the different countries, they were also delegated 2-character country code top-level domains. Say, like for Sri Lanka, for example, like .lk, for example, right? So we use that LKNOG.lk, right? Like that. I think most of your organizations, you may be having domains in .lk or could be in .com and so on, right? And then similarly, there are other country codes like .au, .in, and so on. So currently, we have like 300 or so country code top-level domains, and then 22 generic top-level domains. Now, after 2009 onwards, we started having internationalized domain names. Now, this was initially delegated to countries or country code top-level domains. So this is where, like in 2010 period, even to Sri Lanka, two strings were delegated in two languages. As you can see here, we have .lanka in Sinhala and .ilangai in Tamil, right? So we have these two strings, just like that to different other countries also, because, you know, in the world, there are many countries that use different language scripts. So they could, their CCTLDs could ask for these top-level domains, and you know, they were delegated. So like that, you know, you can see .bharat in India or you know, in Chinese and so on. So there are currently like 60-something strings that has been delegated to different countries in the world, right? Who speak different languages, of course. And if you consider like 2013 onwards, in more recent times, the generic top-level domains have grown quite a lot. As you can see, currently like over 1,200 or so. So these would include things like, say, small, short GTLDs like Sky, for example, or even longer ones like, say, .melbourne, and there are different, you know, there are few examples that I have given here, like .bank, .global, and so on. Currently, like there are thousands of these at the moment. And also there are some IDN strings or internationalized domain strings as well in different languages. So this is how the domain names, especially the top-level domains, have evolved over the period of time, right? So now to give you some context here, so you can see that now we should be able to have domain names in our local language scripts. So if I try to narrow down to, say, Sri Lanka's context, we should be able to have domain names in Sinhala and in Tamil, right? So now let's try to analyze a domain name and see what sort of constraints we have in a domain name. So if you consider this domain, say you have www.cafe123.com. So here the .com is the top-level domain part, as I explained. And then cafe123, cafe-123, that is the second level, and so on. So you can go to third levels and so fourth level and so on, right? Now, when you consider the top-level domain, which is in red here, there are a lot of constraints here, right? We can only use letters, right? So we cannot use things like numbers or other characters and so on in top-level domains. We can only use letters. Because, for example, if you use a number, say 123, that can be misled into an IP address, for example, right? So this is also one of the reasons why, obviously, these kind of constraints are there. So these are some constraints in the top-level domains. Now, for the second level domains, you can see that, now, by the way, these are all in ASCII, right? So ASCII is basically the American standard code for information interchange. That is what the ASCII means, where we can only have some limited character sets or code points, basically. Now, if you consider the second level domains, we can only use letters, digits, and hyphen. So letters can be varied from, say, letter A to Z, and then digits can be from 0 to 9, and then the hyphen. But obviously, like if you see in a keyboard, there are a lot of other characters, right? There could be star, or there could be asterisk and things like that. So these things cannot be used in domain names. So you can only have these sort of limitations that define what you can see here in the slide. So these are the things that you can use in domain names. So these are the ASCII domain name labels. So now let's have a look at this ASCII table, right? Now this is actually just a snapshot of the ASCII table. So as I said earlier, ASCII was basically, you know, defined quite a long time ago. And the whole idea was that time, obviously, to represent the English language, the alphabet, and as well as those other characters as well. Basically what you see in your English keyboard, right? Now, and also we can represent this in a single byte, in a 1 byte or 8 bits. And out of these 8 bits, the first bit is actually sort of reserved as a 0. And then you have 7 bits more where we can actually have 2 to the power of 7 combinations. That means altogether 128 characters or glyphs we can represent using ASCII, right? So this is what you can see. If you put that into a table, you can see, these are all those English alphabets, and then these are different other characters. Also, you can define the numbers from 0 to 9, and then all those other, different other characters and so on, and including, of course, the hyphen. And but out of all these 127 possible one, because we don't use the 0 because that's a null. So altogether 100 out of 127, we don't use all that 127 when defining a domain name, right? These outlined ones are the we use in DNS. Say, for example, the green ones, they are the ones we use in top level domains or even in the second levels and so on. And then if you consider the second levels, based on our definition earlier, we have the digits, and then also the we can also use the hyphen as well, right? So we have letters, digits, and hyphen that we can use in the second levels, whereas only in the top levels, only the ones with this green outline. Okay, so this is ASCII. Now the problem is, so if you are to define, say, some Sinhala characters or Tamil characters here, there's no space here, right? In the ASCII table, there's not enough space. So definitely we have to go beyond ASCII to represent the local language script. It could be Sinhala, or it could be Tamil, or it could be Chinese, or anything, right? You can't put everything into the ASCII table. So this is where we have to have the different other encoding scheme to define these the other local language scripts. So now I have taken 2 examples of 2 domains, considering again from Sri Lankan point of view. I have taken, say, in this case, piriksuma.lanka, right? Kind of, example.lanka or test.lanka, just to give that meaning. And in the same time, also I have used a similar string in Tamil as well. I think this sounds as chodane dot ilange. So this is actually in Tamil, and piriksuma.lanka in Sinhala, right? So if you consider these 2 domains, or in our other way, like these 2 dot lanka and dot ilange top levels, as well as this whole string as the including the second levels as well. Now here, it is defined in something called U label. It's not ASCII. This has to be defined using basically Unicode, because the Unicode came into the picture mainly because ASCII was not enough to represent all those local language code points, and that is why we had to actually find some other mechanism or encoding scheme, and that's when the Unicode came into the picture. But there were a lot of other encoding schemes as well, more proprietary ones and so on, but Unicode is obviously a standard, right? So we use Unicode-based definitions here. So this is why we see something called U label here. So when you see a domain name like this, it is all based on U labels or Unicode labels, right? And again, those restrictions would still apply. Things like, we don't use letters and so on in top level domains here. And then also, we have to have some restrictions or constraints, and these are all defined in a standard called IDNA 2008 standard. So IDNA stands for, again, internationalized domain name for applications. And there were 2 standards. One came in 2003, and the other one came in 2008. So the most recent standard has been IDNA 2008. So that is what we are following now, right? Okay. Now, just to sort of give you again, a snapshot what we have been talking now. So this is just a comparison of the Unicode table, what you see in Sinhala and in Tamil, right? So in Sinhala, for example, these are all the Sinhala characters, the alphabets, and including all these letters. In the same way, you can also see the Tamil characters and the different glyphs in the language. So if you are to read a certain code point, this would say if you are to read this letter ch, for example, so it would be 0D A0. So that's how you read it, right? So 0D A0. So this is actually this is the code point for letter ch, right? Ch in this case. So in the same way, if you say take certain letters, say this one in Tamil, say E, you would read it from here, and then so in this case 8B87, right? So like that, you can always define a certain code point for every of those glyphs in a local language, right? All right, so so to summarize this whole Unicode thing, what we are trying to do with the Unicode is to basically encode the glyphs into code points, right? So glyphs are basically the characters like ch or le in Sinhala. So that's a glyph basically, right? And then we can define it using a code point. Say, for example, code point would be defined something like this. So that the definition would be U plus, then you have a hexadecimal notation here. So letter, the glyph ch would be, U plus 0DA0, or in Tamil, the ch would be, U plus 0B98, right? So U is basically to say it's the Unicode. So that's how the Unicode is sort of, defined, okay? Now, if we are to then send, say, for example, if you have a, say, Sinhala keyboard or a Tamil keyboard, and when you type some certain characters, and basically the computer has to process this, and then the bit stream, basically it has to be a bit stream, right? And then the transmission also has to be a bit stream, the storage and all that has to be a bit stream, right? So now earlier I was talking about different encoding schemes like ASCII and so on, but now we have gone beyond ASCII. But then you have to find some optimal scheme to store and transmit data, right? So we use something called UTF-8, right? So UTF stands for Unicode Transformation Format. And so we are using in UTF, there are different versions or different schemes. There's the 8-bit version, there's 16-bit, 32-bit, and so on. But only thing is that if you use something like 32 bits, that means unnecessarily we are wasting a lot of space, storage space, because 32-bit means like 4 bytes. So if you have to store sometimes a single character, you still have to spend a lot of storage out there. But if you use something like UTF-8, the bytes can be varied, right, depending on the scheme. And also, the other thing is it is backward compatible to ASCII. So we can still use ASCII, which was defined earlier, which means like the English alphabet and so on. We can still use that. And then we can also, go backward compatible. That is also possible. So that is why in a lot of these protocols now, and we use UTF-8 format, okay? So I hope you got some background here. Now, let's talk about this UA or universal acceptance readiness. So the whole idea here is that, say now, if you have a domain, not a traditional domain like something.com or something.lk. Say if you have something like example.sky, right? So this is totally a new top-level domain as based on our definitions, right? And then if you consider something like example.melbourne, right? Or even if you consider something like piriksuma.lanka, or that chodane.lange, these are all, not the traditional ones. So if you give something like this in a certain application, or if you do a search, or if you type this in a browser, can that application recognize this? That is the question. Or even if you have an email address, right? So I could be having different type of email addresses. I can write my email as, say, it could be ASCII in the mailbox part and IDN in the domain part. So it would be something like my mailbox would be Champika, and then the domain would be piriksuma.org. You can also see this whole domain part can include second level domain is a local language script in Sinhala, and then the top level domain is in ASCII, right? Or basically, you know, it's a Latin-based script. So you can have a mix there. And in the same way here, my mailbox could be in Unicode or U-label, whereas the domain can be in ASCII labels. And here, my label, again, Champika, could be, my mailbox could be in U-label or Unicode. And then also, the domain could be in a different language, but still in another U-label, basically in a U-label, right? So you can have various different types of email formats in this case. Also, to make it a little bit even more complicated, because these emails we write from left to right. If you consider, say, champika@piriksuma.org, we write from left to right. But then there are languages, like, for example, Arabic, you write from right to left. So you can see in Arabic, the mailbox is in the right, whereas the domain is in the left, right? So when you write an Arabic email ID, you start from right to the left. So if you give these kind of emails, say now today you join this event by by filling a registration form, right? So you had to type your email address and so on. So if my email address is this, and if I type this in the registration form, can it accept? Right? That's the question. Can the software or the application can accept it? And can it validate? If there are some validation, some parsing, can it do it? And also, can it process it properly and without any issue? And if it is even, say, you know, if we are saving this information in a database, if we are saving the email addresses in a database, can we store it properly, right, in the database fields? And also, if you are displaying it properly, right, for the user, can you display it properly as well? So all these things has to be considered. So when we say universal acceptance readiness, or if you're saying you are universal acceptance ready, that means all your applications can handle all this stuff, right? So that is what we are our expectation here. Now, if you consider, now we have done some surveys to analyze, you know, how organizations and networks and so on, application software, they are ready with the universal acceptance. You can see that only less than 10% of the email servers can handle those kind of emails, right? So it is very low. Only like less than 10% can handle different local language scripts. But of course, when you consider different languages like Chinese scripts or Arabic scripts, because they are more popular, right? In China, there's a big usage of Chinese scripts and Chinese email addresses and so on. So more and more applications now start supporting many of these scripts now. And we have also actually gone through top 1,000 websites globally. And then we also see that fair number, you know, like more than 10% or so, they can still support some of these Arabic and Chinese scripts. But obviously, when you have an average of mail servers, it's quite less. But if you consider, say, the short top-level domains, the current support is almost close to 100%, like 99%, 98%, right? But the thing is that we have to actually get these numbers, obviously, even when you use your applications, when you use your different applications, we have to make sure that, especially now the internet is getting global, and more people using, especially in Asia Pacific region, countries like in India and China and so on, billions of users now moving to use these local language scripts. It is very important for us to support these. I mean, we can't just neglect this, because, say, for example, if a Chinese user is going to send us an email using a Chinese email address, because nowadays, especially even we do a lot of businesses even through emails now, or even online, right? So if someone is talking to us using their local language script or the local language email, and if our email servers can't support that, that's a problem for us. So this is why it is very important as network operators, especially when you manage your infrastructure's mail servers, you have to make sure that you can support these local language scripts. Now, let's have a quick example how these IDNs are being processed. Now, when, say, from a browser's perspective, I'm just taking a browser example here, right? So when a user enters, say, I'm entering this HTTPS piriksuma.lanka in my browser, or it could be even chodhanai.tilange in Tamil, right? So if I just enter this in the browser, what will the browser do? First of all, browser has to do something called normalization. So normalization is, because the thing is, there's certain characters in different keyboards, you can have different key sequences to type different characters. Say, for example, if I take P here, in a certain, say in a Sinhala keyboard, if I have to type per and ispilla with two different key sequences, or versus another, say a keyboard where I can just type the whole P, the glyph in one key, the bit stream has to be same, right? It has to be unique. Whether you type multiple key sequences or a single key sequence, the processing or the bit stream has to be same. So this is what we call doing a normalization. So the software has to do that normalization part. So these are all defined in that standard I mentioned to you earlier, the IDNA 2008 standard. And then the browser will convert this, say in Sinhala, this piriksuma.lanka into an ASCII compatible format. And this format is called actually the Punicode, and this is defined in an RFC. Now, Punicode is a code defined in ASCII where you see in the front this XN hyphen hyphen. So in actual fact, this piriksuma.lanka will get converted into this XN hyphen hyphen, this whole thing, dot XN this. So this part is actually piriksuma, and then this part is dot lanka, right? So that's how.
Sorry for disturbing, Champika. We have to wind up the session within 4 minutes.
Yes, it's all done now. So this is what the browser is going to process, and this is what it's going to pass it on to DNS, basically. So DNS will, because now this is an ASCII string, and then the DNS query can be resolved based on this ASCII string. So that's how it is done. Now, the most important part, actually, just to tell this in a couple of minutes. Now, in an email delivery, what happens is that we have different email servers. So we have a mail, this is the mail user agent, like your email software, the client software. And then in between, you have mail servers, right? Email servers. And then you have the delivery, the client software as well. And we use different protocols. In the middle, we use SMTP as the mail delivery protocol. And whereas actually to deliver to the client, we use POP or IMAP, right? So we have to make sure that, especially as the mail administrators, you have to make sure all your mail servers has to support this SMTP and POP or IMAP protocols to make sure it can support EAI or email address internationalization, right? The thing what we have been talking earlier. Just to show you in an email format, if you actually see when two email servers communicate each other, there is a certain signaling happens between the mail servers, right? So if I just say, when I want to send this email, first of all, the connection would be established. There will be a hello message and then extended hello message, of course. And then it says the receiver has to say that it can support 8-bit MIME in this case. And at the same time, there is actually a signaling flag called SMTP UTF-8. So if you remember UTF, the explanation I gave you earlier, so SMTP UTF-8 has to be supported here, right? So that is the key. So if you are running any mail servers, make sure your mail server software can support SMTP UTF-8, right? That is what we call email address internationalization. Once we have done that, then of course, this particular email ID, whether it's in Sinhala or Tamil or any other script, local language script, can be supported, right? So the whole idea here is that make sure that to send the email properly, we have to make sure all the mail servers in the path has to support EAI, which means all the mail servers in the path should support SMTP UTF-8. So if you're running any mail servers, make sure you enable SMTP UTF-8 in your mail servers, and then you enable EAI, right? So this is what actually I wanted to convey. And if you have any questions, I can take now, or feel free to email me or contact me. Thank you.
Thank you, Champika. But there is the question from Anuradha. The question is, given English is the kind of universal language for cross-border communication today, how do you think we are going to keep things simple to use when it comes to having all these scripting URLs and emails?
Yes, I mean it's a good question, and it's also actually a very pretty much valid question because but only thing is actually there are many countries who even do not use English, even if you, especially if you go to even there are a lot of communities, or even if we have to get the internet to deep inside every country or community, it is very important that we should also provide some provisioning because you cannot expect everyone to know even English spelling, for example, right? If they are to type a domain name in a certain English spelling, so that could be a difficult challenge for some people. So this is why, again, if, as I said earlier, like now in China, there's a huge community, like it is in millions and millions, who use Chinese language domains or scripts for emails. In the same way, in India, currently around 15 language scripts they have requested for because in India, different states and so on, they speak different languages. So there's a big demand for this, and that is also why actually people, it's all coming from the community. Basically, community say there's a demand, and so there is a need for it. But yeah, I mean that is the sort of balance we have to take.
Another question from Shashika Suren Champika. He's asking, can we have domain name starting with digit?
Yes, I mean second level, for example, like as I said earlier, top levels you cannot have any digits, right? For top levels you can only have if I'm talking like say the English, the ASCII, you can only have or even actually for IDN for that matter, for IDN also, no, you cannot have any digits for top level domains, but for second levels you can, right? So it is up to the registry whether to allow it or not, actually, right? So usually, like most of the registries, they do allow digits in their second level domain, just like the example I had, cafe 123.
Thank you very much, Champika. Thank you for your informative speech on universal acceptance and email address internationalization. So yes, you can ask questions in the question and answer panel. So Champika will definitely answer for that. Okay, thank you very much, Champika.
Thank you very much, and nice talking to you all.
Okay, our next presentation is by Jeeva Padma Sandagomi. Sandagomi is an IT professional with 12 years experience in both public and private sectors. He is presently heading the Enterprise Risk Management Division at Mobitel. During his tenure at Mobitel, he has been leading different roles and responsibilities at Mobitel, including IT strategy, project management, IT security, and revenue assurance. Today, he's going to talk about cybersecurity dimension in the telecom industry. Ladies and gentlemen, welcome Sandagomi to LKNOG4. Sandagomi, over to you.
Good afternoon, everybody. I hope you can hear me also. Right.
Yes, we can hear you.
Okay,
And
thanks for the introduction. Let's go on. So my topic today will be about the cybersecurity dimension in the telecom industry. I think much talk about the topic in the early sessions as well. And thank you all for the organizers for having me in the LKNOG session for this time. So we'll move on to the presentation. Yeah. So when I'm selecting this topic, the cybersecurity dimension in the telecom world, I was actually had another thought whether I'm using the correct word. Meaning, can we any longer identify ourselves as telco industry? Because I think the entire audience here would be telecom industry. But can we any longer name us as telecom people, right? Because at the world we live today, our legacy telecom industry definitions has been very drastically changing due to the impact of the digital disruptors. We know in the last decade, we see the disruption they made, like either Skype or WhatsApp or Viber and other digital disruptors came into picture as OTT players in the world. What it made real to the change in the industry business models in the telecom industry. And also, there's another fact that I want to share with you in this regard. 3 years back, actually, in the US stock market, there are stock classification as per the industry. And for the last centuries, actually, they use the telecom industry as one industry classification. Even in the standard classification, they use the telecom industry. But 3 years back, actually, they merged it with the media industry, and they now call it as CSP, so the communication service providers, and all the public listed telcos in the US stock market are now trading or considered together with other ICT players like Disney World, Facebook, Netflix, and even the Alphabet, the Google's custodian company. So that's the world that we are living in, and entire telco platforms are transforming hugely with the technology transformations as well. If we see today, we are talking about so many transforming technologies like SDN, software-defined network function virtualizations, the cloud, and again in Sri Lanka, we are talking about the 5G advent. So all these technologies are hugely transforming the telco industry boundaries. And again, not about even the telecom industry, but across the world in all the corporates, digital transformation has become a buzzword. All the board members, the CEOs, and the top managers are talking about digital transformation, how to move their traditional business processes enabled with digital enablement. So even in the finance industry or the manufacturing industry, this has become a buzzword. And the main point is, telecom is the enabler in all this digital transformation. We as the ISPs has a bigger role to play in this entire digital transformation we are talking in the world. Then the other factor is about the COVID pandemic situation, which we never thought to assumed by anybody one year ago. Right? All of a sudden, entire world has to actually change their way of living, way of doing business. And again, it has been identified that by most of the world leaders and the technology leaders and the corporate leaders as the telecom infrastructure is a critical infrastructure to connect their live wire with the rest of the world. So these are the new parameters come into play in the current context. And again, there are new regulations come into picture, like, a few years back, the European Union came with the GDPR regulation, and locally also there are certain initiatives in this domain. So all these regulations also shaping our industry. So this is the telecom world we live in. So having said that, we'll move to the another stat that I will share with you, which I taken from the GSMA stats. So the GSMA published about this mobile economy in 2020. And I don't want to go through each and every number points, but I would like to draw your attention on 2 or 3 areas. One is, that as of today, or as of December 2020, we have more than 7.8 billion population on this planet, right? And as per the GSM stats, there are over 5.5 billion people on this planet are using mobile connection, right? So it's a significant percentage. I believe it's now near to 70% of the world population are connected. And nearly 60% of them, actually over 65% of them are having a smartphone, meaning they are connecting to the internet by any means through their mobile phones. And the other important factor is, you see the number of IoT devices connected as at last year is again 12 billion. So what does that mean? There are 12 billion devices are talking each other in the internet, which is actually more than double the population in this world, right? So this is the interesting facts that we are talking about the mobile industry in the world arena. And if I move to the topic that I'm talking about, the cybersecurity incidents. So I thought of sharing with you key incidents happened very recently, or rather within the year. So I can't actually miss the major one, which happened very recently about the SolarWinds security breach. I think most of you are network working in the networking area, so that should be all familiar with the SolarWinds application, IT asset management software. Whereas it is alleged that the set of Russian hackers actually managed to get into their development servers and able to set up some backdoor Trojans or the malware into their patch updates and managed to download these payloads to customer accounts which they need to attack, and especially targeting the US some departments like defense and telecommunication department. So it has been a major breach, is considered to be a major breach which happened at the lower part of the year. So apart from that, there are so many, which I don't want to actually go to all the details, but the Twitter again, there were certain highly recognized Twitter handles were being compromised, and through this Twitter handle, there was a request for Bitcoin request came promising double the return. So accordingly, these hackers would collect over $100,000 through Twitter. Then again, in the hotel and the recreation sector, the Marriott and the MGM resorts actually their customer details of millions, 5 million customer details has been disclosed in the Marriott hotel chain. Then again, about 10 million guest details were breached or disclosed through MGM resorts hacking activity. And even this Zoom application recently was hacked, and the 500,000 user accounts being published in the dark web recently. So likewise, actually, there are so many hacking incidents are happening. And I recently saw that in the world, every 39 seconds, there is a cyber hacking activities happening. This is the gravity that we are talking. And as per the European Union Cybersecurity Agency, that they rate the malware, web-based attacks, phishing, and web attacks, defacing, spam, and DDoS are among top 15 cyber attacks, right? So this is the situation we are talking. So if I go to the detail about the cybersecurity landscape that we are talking, as I mentioned, we are actually dealing with highly sophisticated cybersecurity attacks these days. There are APTs, advanced persistent threats, the military-grade malware installations, then the zero-day attacks, the targeted phishing attacks, we call spear phishing attacks, the ransomware, and the rootkit exploitation, and so on. So today, the problem is actually the cyber war game is become among the political rivalries. We see actually always the Russian hackers are blamed for penetrating US departmental information. And we see certain Chinese hackers are being charged or complained about accessing Western countries and the US databases. And we always see that the North Korea and other, certain Eastern Europe countries are actually being, charged for these type of things. So it has become a political rivalry game in this cyber war game. And again, even the terrorist groups are actually heavily using cyber activities as weapons. In Sri Lanka also, in certain period of time, we see an aggravated cyber activity from outside to the world targeting government institutes and ISPs in the country. So it's a normal for the day, right? Then other aspect of this cybersecurity is that actually, across the world, all these manufacturing arms and other areas are using operational technologies converged with the IT. So with that, there's a lot of high risk is actually generated because of these convergence happening without proper security adherence or basic security guidelines complying. Then again, across the world, we see the cybersecurity has become a board topic. All the board members are talking about it. Because the earlier cybersecurity was considered to be an operational risk, but today they no longer take it as operational risk. They take it as a board risk or a strategic risk. So all the investments are also being aligned with this risk profile take into consideration. Then again, we see I believe most of the telcos here in this forum has the SOC Security Operations Center operations, SOC operations. So there's increasing interest on implementing SOCs with the focus of advanced threat detection and the analytics part. So the people are trying to use the advanced threat detection using the AI and ML, advanced artificial intelligence and the machine learning. Then again, the cloud has becoming the mainstream computing platform these days. That we are moving all the networks are moving from their bare metal infrastructure to the cloud these days. So that there's a new set of security is required to manage the cloud-related security challenges. Then again, from the customer side also, there's an increased demand about their privacy and confidentiality. So all the customers who are obtaining service today are demanding or challenging about the security of their data. So the new data security governance frameworks are emerging to address these stuff. So I'll share with you 2 points in this regard. One is about the World Economic Forum, where every year they published top business risks for the enterprises, and the cyber risk has been there among the top 5 risks for last couple of years. And this year also they have identified the data theft and the cyber attacks as 2 of the top 5 global risks for the businesses in the world, right? And the other point is the Gartner prediction. Gartner we normally take it for certain trustworthy predictions. The Gartner predicts the cybersecurity rating. They talk about cybersecurity rating, like the credit rating that we use for the corporates today. So they talk about the emergence of cybersecurity rating, which will be a key factor or parameter to assessing the risk level of companies when we are interacting with each other. So that is really important for telcos, because telcos are boasting about the very spreaded heterogeneous partner ecosystem. If you take a telco, we have our interconnections. We partner with our peer operators. We partner with our dealers. We partner with our retail chains. We partner with our content providers. So it's a very complex partner ecosystem we manage as telcos. So in this realm, I believe cybersecurity rating will be an important factor when we trying to connect with external party, whether the external party is complying with the minimal security standards or not. So this is the context that we are talking, and I will now try to move to the telco industry specifically. And I would like to share with this latest EY report as well. EY every year actually publishing a report on top 10 risks for the telecom industry. And I have seen for the last couple of years, the cybersecurity risk has been one of the major risks that they are highlighting among the top 10 risks. So this year also, for the year 2020, They say the underestimating changing imperatives in privacy and security and trust as a main risk for the telcos among the world, right? So we have to actually seriously take the customers' privacy, security, and trust, which needs to be taken care of. That they have understood as or recognized as one of the highest risk for the telcos. And another interesting fact I would like to share with you is they have assessed the security function of telcos in the world. And most of the telcos security function is either compliance driven or crisis driven or a tool focus. They are not actually strategic or proactive mode operation currently that we can see. So the most of these security function at telcos, they say either we have to, running due to a compliance requirement, either it's ISO, GDPR, or any other regulatory compliance requirement, or because they run it because they were being attacked previously, and hence that they have to actually safeguard the operations, or they have just invest on tools or the technologies only. There's no specific strategy and the framework behind the operating for the security operation in the telcos. So this is the outlook of the global telecom industry, especially in the cybersecurity. So we'll move to the evolution part. I just want to share with you because we have been, as the telecom industry, we have been talking about multiple waves starting from 1G, 2G, and we now embracing the 5G. So with the technology evolution also, the application has been strengthened, and now we talk about the connected world, but similarly, the threat vector has also been increased. Now we are talking about actually cyber warfare, espionage, and still the APT, advanced persistent threat, and DDoS attacks, and so on, right? So this is can call as a change in telco security landscape. I believe that, as I mentioned before, we are still predominantly in a bare metal network. Our networks are purely bare metal most of the time. And we still talk about 3GPP security standards in our networks. And we still embrace the perimeter security, because when we are defining our security boundaries, we by default, we believe that behind a firewall, there are good people, and, beyond the firewall, there are bad people. The hackers are there. So that's a standard, the concept or the theory that we worked in defining perimeters. But the perimeter security is no longer valid with the advent of cloud and other technologies. Actually, these concepts are fastly diminishing. So the network zoning and the traffic separation are still we are practicing, and we still talk about the network element-based security, that protecting the specific network element and so on. And again, I think the silos operation in telcos, we see the telecom nodes securing telecom nodes and the IT enterprise nodes is a completely silos operation. I think this point was raised by Asel also in his presentation in the morning. So we see there still the operation in the security in the telco industry is silos where that they don't talk to each other, or there's less communication between these two parties, right? But actually, going forward, how this landscape will be changed, it is interesting to see that already there are certain changes happening in the policy level as well. If you take in the GSMA, earlier there were GSMA work groups, 2 work groups for fraud management, and there's another work group for security. But later on, actually, they clubbed together and they now call it a fraud and security work group. Whereas that most of the subject areas that they are talking are in parallel, so they understood actually it's with the current context, it's better to merge these areas. So as I mentioned before, the network perimeter level is diminishing. So we see the 5G based services, whether it's standalone or non-standalone implementation, are entering into the network, which actually adds another set of security challenges. And as I mentioned about the multi-partner network, it's a complex connectivity arrangements demanding trusted and trouble-free infection. And again, we are today talking about zero trust security models, right? And the SIEM environment that I believe most of you guys are using SIEMs in your networks, security information and event management systems, now are being empowered with threat intelligence systems and as well as AI, artificial intelligence-based systems to empower the detection mechanism. Then again, the increased demand from the customers on the confidentiality and the privacy. So these are the because of this demand that we have to increase our readiness levels in the cybersecurity operation. And this regulatory level also, there are push from the regulators and the policymakers about these areas. So this is the landscape that we are talking about, and which will definitely will be changing very soon with regard to the cybersecurity in the telco networks. So since we are having limited time, I will not actually touch upon detail on this stuff, but this talks about the mobile security lifecycle management. It's start from secure device management and mobile OS and application patch management, then about the security threat analysis and the security monitoring. But in fact, as telcos or the ISPs, the first two parts, we have very limited control about the secure device management and the OS and patch management, whereas our focus mainly about the threat analysis and the security monitoring. Then I just kept it aside because the cyber attack types we today categorize into these forms like cyber activism, like hacking activities, and the cyber crime, stealing data or for the making financial losses. Cyber espionage is another major thing where the business rivals and nation states are engaged in this type of activities. Cyber terrorism, we talked about it. Actually, we can see happening it in a greater manner, and the cyber warfare again. So these are the cyber attack types. And I would like to share this concept. I believe most of you perhaps would be familiar with this cyber kill chain and the attack framework, MITRE attack framework. Cyber kill chain is a military based model, whereas whenever a attacker is trying to recon or gather information about the exploitation and the steps that he is following to get the access and get the command and control and deploy his objectives is described in these 7 steps as cyber kill chain. So this is actually useful when analyzing and tactics and techniques of a attacker. And using this framework again, the MITRE framework has been developed. I think there are a lot of parallels between the cyber kill chain and the MITRE attack. But I believe most of you would have been already familiar with this framework. It basically talk about 3 terms like TTP, we call it tactics, techniques, and procedures. Whereas tactics actually call about the adversary's technical goal, why it is doing, and technique is about how it actually doing, and the procedure is a detailed description of the technical implementation of this tactic. So this is this MITRE framework is being a vendor neutral framework, and we see a lot of security devices and the solutions are nowadays in line with this, complying with this MITRE framework, so that even if you are assessing a security solution, the MITRE framework could be a useful reference guide or a knowledge base in assessing the generally available adversary techniques in the current world.
Sorry for disturbing. We have
fine, right? Yeah. Okay. I'm wrapping up. So the other side is actually about the IoT application, because that, as I said before, we are talking about over 12 billion IoT devices connected to the internet. So it's more than the human population on this planet, right? So these devices, we see more than the actually mobile devices, the IoT devices is lacking the basic security guidelines which required to be connected. So there are a lot of repercussions which regard to the IT security in this aspect. So I have listed down these security challenges regarding the IoT, like public safety, digital health, mobility, and these are the applications in the IoT industry. But one classic example is actually very recently, I saw in the BBC News that the German police is actually going after a hacker set who has hacked a German hospital in Düsseldorf, whereas that they actually they hacked this hospital system and shut down the applications in the hospital management, whereas that due to that incident there was some patient death happened, and then now police is trying to charge the homicide charges against these hackers, which perhaps would be the first charge against homicide charge against a hacker related to the health industry in the world. So we see these cases are coming up because of the way I chose this slide to share with you is that, the impact in the IoT sector would be really significant than other sectors that as we predicted today. So finally, I would try to upon this post-COVID world. We see with the unprecedented COVID pandemic happening, all the telco networks has become a critical digital infrastructure. Overnight, actually, all the corporates are trying to work from home and bring in their, manual works to digitalize and so on. So a lot of actually security vulnerabilities are exposed in this process, and parallelly we see a lot of the count in the security breaches are also increasing. So the FBI has actually reported there is a over 300% increase in the cybersecurity incident on daily basis with the COVID incident, because most of the people are trying to access their corporate infrastructure from home and related incidents are happening. And then even Google has claimed there's a drastic increase in their phishing and spam mails with the COVID in the Gmail, whereas that per day they are blocking over 18 million coronavirus related email scams per day. 18 million Gmail mails they are blocking at Google, right? So this is the threat behavior we are seeing. And the other thing is actually with this new normal, we need new diverse security skill set to cover the wide security spectrum. So this is the context that we are talking. And finally, I would like to touch upon the local telecom industry. We see in the cybersecurity status in the local telecom industry in Sri Lanka, the policymakers started talking about the cybersecurity. The Computer Crime Act is the act that currently enact in the legislation. But there are two important bills are in process now. One is the data protection bill. Other one is the cybersecurity bill, where they have suggested a lot of good suggestions to be implemented, like a national SOC and defining telecom infrastructure as critical infrastructure and so on and so forth. So if these bills are being approved by the parliament and become act, then there will be a lot of changes will happen in the cybersecurity segment in the telecom industry today in Sri Lanka. And again, we see both our regulated TRCSL as well as in the banking sector, the central bank actually imposing a lot of security controls. We see some of the regulations imposed by the central bank is actually relevant to the mobile industry as well, because due to this mobile money and the payment related applications, we have to comply with both regulators like central bank and the TRCSL. And other important fact is about the cert. In Sri Lanka, we have a bank cert, but we don't have a telco cert yet. We even actually raised this necessity in a couple of different forums before. And at the moment, I believe TRC is still working on it and it will be realized very soon. And with that, I believe a lot of these kind of cybersecurity activities can be shared among peers in the industry for fast responses and so on. With a lot of things that we can collectively work together to overcome these issues. Then with the telecom networks, as I said, we all become critical digital infrastructure. And the other aspect I want to share with you is, we boast in Sri Lanka about over 100% mobile subscription in Sri Lanka in terms of population. So in other words, the entire population database, whether it's usage data or the customer demographic data, all in the custody of 4 mobile operators. So we all have to actually work together to strengthen to protect these databases. If any of these databases being leaked or exposed to the outside, the repercussion will be really, really critical. And we see everywhere in all the telcos, the board level attention, as I mentioned, it's no longer an operational risk. So as the last slide, I would like to share with you this as the party note. This is from some thought from the World Economic Forum. Early this year, actually somewhere in March, they published this paper where they suggested all the internet service providers or the ISPs in the world to try to implement these 4 recommendations from the World Economic Forum side. So I will briefly go through it. One is actually about the protecting consumers, because that the whole objective is, safeguarding the cybersecurity in the world. So the number one is protect consumers by default from widespread cyber attacks. So we see we as the telcos, we has the first line of defense, but at the current context, we do very minimal to protect the customer end devices, their activities, cyber activities, to protect that we have very limited control. So what the World Economic Forum requesting all the ISPs world is, protect the consumers by default through mechanisms what we can implement at the moment. Because the research has found almost 85% of the botnet infrastructure are located in consumer ISP networks, right? So it's that on that basis they are suggesting that the telcos and the ISPs to control these activities. Second part is about the raising the awareness, raising awareness among the customers, because that we see it is in Sri Lanka in sense that it is really in a lower state, whereas that we see our customers are blindly clicking any web ad. They are just sharing their personal information with external parties and so on. So most of the customers are actually the behavior is like that. So as the ISPs and the telcos, we have a responsibility to educate our customer base about the possible threats and the risk in this kind of cyber behaviors. Then again, third one is the work more closely with the manufacturers and the vendors, defining a minimum security baseline. So this is actually much more related to the IoT devices as well. The fourth one is take action to show up the security of routing and signaling to reinforce effective defense against attacks. We see even GSM has published SS7 signaling vulnerabilities and control actions where the telcos can take place. So there are a lot of things that we as an industry can work together to implement in controlling these routing and signaling security. So these are the four recommendations made by the World Economic Forum this year from all ISPs in the world. And I would like to leave this as the parting note with you. So I think that's all, and I would like to sign off from that moment. Thank you very much.
Thank you, Sandagami. Thank you for a timely speech. As we are running out of time, I will invite our next speaker. Our final speaker for the day is Professor Roshan Ragel. Professor Roshan is a consultant at the National Learn Lanka Research and Education Network, and he is a professor in computer engineering at the University of Peradeniya. He has spent many years for building and managing information technology infrastructure dedicated to supporting the needs of the research and education communities in Sri Lanka. He is also an advisor for LKNOG. His speech is about online teaching and learning during COVID-19 era. Dear Professor, over to you.
Thank you, Juwanti. Good afternoon, everyone. And the topic I have is online teaching and learning during COVID-19 era. So I'm going to just share an NREN experience on how this time and as an NREN and an ISP for academic and research community, how we are coping with the situation. So that's the idea. So we'll start with a quick intro to the NREN I'm talking about, Learn, Lanka Education and Research Network. We started the concept of an NREN for Sri Lanka started very long time back, 30 plus years ago. And the last 10 plus years, we are operating as a limited guarantee company. And we have 16 full members, 15 associate, and about 20 affiliate members. And so we have altogether these members having physical connectivity of about 90 connections. So we are small in numbers, but and also, like I said, we have celebrated our 30th anniversary last year from the as a concept of a national research and education network, and at the same time, we also passed our 10-year as a company. So just to give a quick background on how our network looks like. So we have basically, let me take a pointer. So we have our member institutions, which are, like I said, having as of now 90 plus, almost 100 connections. And these connections are going, they are put together through a VPLS network, and starting from the smallest members having about 10 MB. So we are increasing it to 20 Mbps, and like the largest ones are 2 Gbps connections. So that's like the links we have. We have about 100 links, and in addition, we also have about out of these 100, the links that are having higher bandwidth or subscription. They also have another backup link from a different service provider, and we have about 25 of those also connected. So through these two connections, we are going to the internet through two service providers. One a 10G link, another one 4G link, so a 14G link internet. Plus, we are also connected from here to the SLT-IX, the internet exchange that was discussed at the beginning of today's session, like the afternoon session. And in addition to this, we also have a 5G connection to the Singapore global switch in Singapore. So where we are also connected to Google. Plus, we are from there we are connecting to the rest of the Asia's end or the academic network. That is through a 1G link. In addition to that, we also have another 1G link connecting to India. So NKN is our counterpart in India, National Knowledge Network. So we are connecting to them through another 1G link. Plus, we are also connected to LGN, Lanka Government Network 2, through a 1G link. So these are the connectivities we have and the connections we have. In addition, this 5G link connects to things like the network like Internet 2 through the Singapore's Research and Education Network, which is called SINGARET. So these that's like a big picture of how internally we are connected, how we connect externally. In terms of like a backbone bandwidth related to the different districts in the country. So we have about 10G of our bandwidth, like our backbone of in Colombo, Gampaha districts, about 3 in Kandy, Badulla, that area, about 1G in the east, again 1 in the north, and 1 plus in the south and so on. And also like mid, we have another one in the area like Rajarata and so on. So this is like a spread of how these 90 plus connections are distributed and the bandwidth or the backbone we have across. So now let me just come, so that's the background, and let me come to the topic, which is how we are coping with this particular pandemic situation, what we are doing. So we, sorry, when the pandemic hit somewhere in March in Sri Lanka, we everything was closed down, as you know, and we wanted the universities to continue operating. So we'll so tell you what we basically did as an academic community plus as an ISP to the academic and research community in the country. So that's what I'm going to discuss. So we basically had our own, like I was showing you, this network infrastructure, plus we had 2 main systems that were in operation. One, the learning management software systems in each one of these institutions, like this 90 plus connections. All of them had 1 or more of the learning management system, which are like centralized software or internet computer, like web-based technology, where we can interact, share material, communicate mostly through text, discussion forums and whatnot. Right, so that's what we had. And then we also wanted a replacement for the physical interaction, like the meetings, the lectures, those sort of things. And we, in fact, like had as a service provider, we were providing them with the state-of-the-art video conferencing solution. In fact, like what we are providing is the Zoom video conferencing solution, the same one we are using right now here. And that the utilization of which was not a lot at that time. But then we, with the government, with various other parties, thanks to all our partners, the ISPs, we were able to provide a better service, like all of us discussed earlier also, through various initiatives. The country's internet service provider infrastructure has become the live wire of every activity, including the academic and research activity of the universities or the National Research Education Network. So the same thing happened here, but like one good aspect, something that made all this even viable for students and also others is that this whitelisting of IP addresses of the network that happened where all the ISPs provided the data for the users free of charge. So we started advertising this, started like putting together all these institutions and their learning management systems together, and we started collecting data. We started like promoting them to do more, get engaged and start doing these activities. And so it all started very fast. Like the universities were closed on the 19th of March. In fact, like 2-3 days into the the national closed down, and I mean national, and also at the same time around the same, like within 4 or 5 days, you can see like we started discussing with the ISPs. The initiations were taken by the UGC and various others, and we started getting these things rolling. Right. So I just to show you how it all went. This data what I'm showing here is the learning management system activities across all the 90 plus, like all these members who like 90 plus connections or more we have, and their membership, which means basically all the universities and state universities, private ones, and like very few of them, and then the colleges, all these Univotech, vocational teaching institutes and all that. So altogether we had, during that period from March to August, we had a lot of activities, and like compared to the beginning, we had like about 3 times more activity during that time online on all these learning management platforms. And so you can see in terms of progress over the weeks. So this is what I'm showing here is just what happened during the time from March to August. In August, we reopened like every other industry, the higher education sector and the education sector also, we reopened everything. So this data is until that point where we are showing how the blue color curve here is the learning management system activities, which is in millions. And then we have the number of users logging into the system weekly on in hundreds of thousands. Right. So just to give you a context, the number of users in, if you take just the state universities, the number of users in the state universities are about 150,000, which is very small compared to the whole country. And so those, and also like if you take private and also vocational colleges, the numbers are about 250,000. So that's the numbers of users. So in addition to this, we also, like I said, we needed another solution where to replace the face-to-face meeting, lectures, Viva, and all sort of different activities we conduct in the higher education institutions, and research, collaboration, discussions, all sort of presentations, all that. So we we were having this Zoom connectivity, and also we had like centralized federated identity management system. So where all the institutions had a central dashboard through which all our members had a central dashboard managed by Learn, and we were able to any users from member IDs, identities can come into the central system through the this federated identity management. So we have connected that with the Zoom's identity management, and therefore we were able to provide this service to all the lecturers, teachers, administrators across all the institutions or member institutions. So at the same time, we also had a problem, like around this time, we had this problem, like as you know, a service like video conferencing solution like Zoom will consume reasonable amount of bandwidth when you want to use it for teaching, learning. And therefore, what we have done, like I mentioned earlier, is the service provider, other internet service providers agree to provide data free of charge for our students, as long as the traffic is within the research and education network. So, but a service like Zoom did not have that feature, like we don't have that feature because like Zoom servers are in the cloud and they're outside and so on. So within like a couple of weeks, we figured this out somewhere in March, and in April, we have set up our own on-prem Zoom video conferencing servers or video conferencing solution. So basically, they are media servers which are running on the Learn network. So therefore, the service providers will still be able to identify them as, or everyone else will still be able to identify them as the education and research network traffic. And we did this on-prem solution locked down in offices or homes, all remotely. And we have put together a number of such servers across different member institutions and also the data center, Learn data center. So when we did that, so these numbers, what I'm showing here are from March up to like last month. There we have, up to now, we have hosted about 350,000 meetings in Zoom. And we have had about 15 million participants coming and joining these meetings over the last 8 months. And so these various numbers, like how these peak numbers are, like this number of participants at the beginning, you can see the numbers are very small. The first peak is like 20,000. And first wave, we had about 80,000 towards the end. And second wave, the numbers per week has increased a lot, as you can see. And all-time peak, we had in a week about 1 million users coming and joining the sessions in a week. Right? So that's like big numbers. So here is a better understanding of what has happened. So we had, we are putting this together in 4 different parts or 4 different zones, pre-COVID, and then during the first closure of universities, we are calling it, how the number of participants coming online on our Zoom platform has increased. And then, as you can see, somewhere in August, September, we started opening, and therefore the numbers are reduced. And the black one is the number of meetings that are hosted. And you can see what has happened in October when we started again. So from October onwards, again, all of our universities are running online again and using Zoom platform. And you can see the numbers have gone skyrocketed during this period, November. And so for instance, like how do you read it? This graph is that right. So is that in November, we had about 4 million users coming and using our, like joining meetings in the platform, and about 80,000 or 90,000 meetings held in that month. Right? So that's how things have grown. And these numbers you can see keep on increasing. And also during this period, like you can see with the load, we also had to cope up with the network bandwidth limitations and bandwidth changes that we had to do, plus also the server side, how we can cope up with the server. So, I mean, like, because, you know, like we are running on-prem. And we, as of now, we run more than 100 VMs, or about 120 VMs for supporting this number of users. So that is just numbers, and like these are again numbers, how they look on a daily basis. Say, for instance, we at a time in our platform used to have about 150 at peak, the maximum time of utilization. We had about 150,000 users connected to the system at the same time on a video conferencing system. So as you can see, as of like now, we are not normally using video. All the users are not using video. All 150,000 users are using video. Then the bandwidth that we require, we don't really have, and although the server requirement we don't have. But I am also talking to others in the Europe, for instance, Nordic countries. They have similar number of users, and their bandwidth numbers are like 5 times higher or 10 times higher than what we are utilizing. So that is possible only because we are using this without video. Without video and only sound when needed, right? So and video of only one person who is talking and so on. So that's the numbers, and I can also show you some comparisons in terms of how this number of users have increased over time. So compared to like the first week of lockdown, we have about 50 times increase in the number of users. Right? So we are this comparison goes to time where there were not lockdown, like where there's not much usage. But compared to the first week, now we have about 50 times more users, 50 times participants coming in and using the platform in the last weeks. So that is in terms of users, number of participants, and so on. In terms of traffic, we can see like this. These are coming from different zones we maintain for media servers. So we have some in the cone, like in our data center, some are in our member institutions like Moratuwa, Kalaniya, Japura, and so on. And we can see the peak utilization goes to about 4G gigabits per second. Altogether, this is like this graph is coming from last week. And over months, how things have progressed, you can like how things have changed, and you can see like the utilization of the Zoom traffic has gone down in somewhere in September for the same reason. You can see that as well. And you also can look at how this has happened for the internet exchange. So we are directly connected to the SLT and the Dialog data centers, and therefore, or their switches, and therefore the internet exchange traffic is the one that are coming from other service providers into our network. So here again, you can see the previous, like, so you can see some so how the traffic was somewhere in January, February, March, and then you can see what has happened from April onwards. So April onwards, the numbers have gone to 1G. In fact, like the link we have, there is a 1G link. As I was showing you earlier. So the traffic has reached its peak at times, and it has gone back, and then again coming back to almost like the same 1G total. Right, so 900 plus 100 outgoing. Right, so 1,000 1 gig. So how it looks from a member perspective. So I have taken a member as an example, member network, and this member is hosting some Zoom like media servers. So somewhere in January, February, March, you can see the traffic is outgoing, meaning like from the member, so going to the member. So so this member has a 2G link, and you can see the traffic is all out here up to 2G at times. And now from March, you can see the number like the it has reversed. So more on, like, in fact, like it's reversed, and it's both sides actually, because it's media servers, and you can see how things are happening. Like again, somewhere in September, or August, September, you can see again the pattern like pre-COVID. Plus the green lines are also there, meaning there are some meetings also and traffic happening. And again, you can see now we have going back to like more, in fact, like higher compared to what has happened in May, June. So here you can see the numbers are much higher. By the way, these two graphs are drawn to the same scale. The second one, there's no scale, so it's just the same scale you can assume. Right, so that's how the traffic has happened. In addition to all this, we also have provided or set up a few other services during this period. One, we have set up an identity management system for individual users. So we are maintaining our own EduID setup. So EduID is a service that is provided by Entrance across the world on providing member identity for users. So our things like students, teachers of universities can subscribe to this service, and we are like at Learn, we are managing this service ourselves. And this can, so EduID can provide services like email addresses, it can provide EduROM facility, EduGain, and also as of now we also have subscribed to Microsoft Teams and Microsoft like A1 license. So those are also we have done. In addition, we also have enabled, this was a long-term discussion in my last talk in LKNOG4. I was talking about how EduRoam is used across our member institutions. Now this year, like at that time, I also mentioned that we are planning on going public, meaning having our EduRoam connectivity across other, like other places, not just universities. So we have opened or started launch that project. As of now, we have, in addition to the member institutions, so all our member institutions who are enrolled in EduRoam, anybody can, like say, for instance, I'm a lecturer in University X, I can go to University Y and connect to the Wi-Fi network. They are using my credential from University X. So that idea is there, and that was there for a long time. But now what we have done is we are broadcasting our EduRoam ID or EduRoam SSID at public places through a service provider who has public Wi-Fi. So we have, as of now, 100 such hotspots enabled. Railway stations, bus stands, hospitals, and shopping malls and places like that, where EduRoam is now enabled, and our members can go, like those who have access to Wi-Fi access in universities can go out and connect to EduRoam and use the same facilities. So that is something else that we had done during this period. So that's all I have, and thank you for listening. If you have any questions, I'm happy to answer. Thank you.
Thank you, Professor Roshan. Thank you for all the details and statistics you have mentioned in your presentation related to education and research network in Sri Lanka. Are there any questions here? Seems no, but you can ask questions later. So Professor Roshan will answer to them. Yes. So it's time to, yeah, now it's time to give the chance to Tilina to talk. Tilina, the president of Lanka Network Operators Group. So Tilina, it's over to you.
Thanks, Jivanti. So it's time to wrap up things. But before that, I just want to share something with everyone. There's a small survey link that where it's better if all can go to that link and then fill in the questions. Also, I will share the link with the Q&A. So, okay, so with that, it's kind of the end of LKNOG4, and this is the opportunity, my opportunity to thank you all before wrapping up. So first, need to give our attitude to SLT and AWS for supporting us financially, and then APNIC for providing the Zoom platform. Without you all, it might not be possible for us to make this event a success. So thank you for all your support. And then I need to thank all the speakers, Tashi, Asela, Kaushalya, Champika, Sandagomi, and Professor Kagel for their valuable time and for the support to this LKNOG community. And also need to mention our team, especially Ubudu from the APNIC end. He was behind the screen all the time from the morning. And then Jivanti, our co-moderator. Thank you, guys. And then the other committee members, Dulip, Nipuna, Samantha, Niranjan, Subha, Srimal, Rajiva, Siam, for their different various levels of supports. Thank you, guys. And finally, thank you all for participating and spending your busy time with us this whole day. We will be having some big plans for 2021, where we will be targeting to do some large events next year physically, hopefully. And until that, we will be wrapping up this year's LKNOG and look forward meeting you physically in an LKNOG 5 event. Thank you and stay safe.
Okay, the live stream will stop now. And I will end the meeting in few seconds.
Thank you.
Thank you, everybody.